Okay, hi guys. Welcome to the cloud workshop. Today we'll be doing a bit of like fundamentals of not really cloud. I think before lunch we'll be doing a bit of Docker. I don't know if you guys heard of Docker, and some other web techniques. And then after lunch we will start going to AWS. Those who just came in, you need to set up your AWS account. Right now, in the morning, we won't be using AWS yet, but after lunch, or in fact, if we have time, even before lunch, we may start doing a bit of AWS already. So, just make sure your account is set up. You need a like credit card or like debit card to verify your account. So, if you don't have, you can ask your parents. There's no like additional charge lah. Like, it won't it won't like cost you like $10 or something. It's like free, okay? But it's just to verify your account. So if you don't have one, you can text your parents, ask them to or even ask them to help you create the account. I don't know. You have until like after lunch to do it. So no rush. Yeah. Okay, so we start with a bit of like more fundamental stuff first. Docker. Anyone here heard of Docker before? Okay. Kubernetes. Today we're not doing Kubernetes, but yeah. So there's quite a lot of you. Docker is like, it's basically like a containerization software lah. So you can build containers to host different services on Docker, right? And so these services, they are defined in like a text format. It's like a bit of like configuration files lah. And it lets you like create a group of services very easily. Like you can just like push the Docker file, your Docker compose to GitHub, and then after that you can just spin up on another host. Yeah. Reason why I wanted to go through Docker is because later on when we talk about like cloud VPS like instances, right? This idea of like different containers networking with each other is quite important lah for us to understand. So here you can see this is a diagram of what Docker looks like. So okay, we start off with infrastructure is your hardware itself, right? Your laptop or your server rack or whatever, and then you have your host. And on your host, you can run Docker. Docker is running on top of your host, right? And Docker itself, there will be one Docker daemon that's running, and many applications, many different services will be running on the Docker daemon. These services is not shown here, but so they can be separated by different networks. So let's say like A to C is one network, D to F is one network. So containers A to C, right? They can't communicate directly via the Docker network to each other. But of course, if your host has a public IP or something, then A can connect to connect to the public IP of your host, and after that connect to F, for example. Yeah. So there's this idea of segregation here. Your applications can be segregated by networks. So this segregation will be quite important for, like, we need to understand this segregation lah, because when we are exploiting cloud targets, there will be segregations in our networks, in our permissions. So you need to understand this idea. Yeah. So I already talked about isolation of the services. For example, if you manage to get RCE on a certain container, right? Of course it's possible to escape. There's this thing called Docker escapes. And also, if you misconfigure or if you give your container privileges, then it's very easy to escape. But with the default settings and assuming your Docker is safe from Docker escape, even if your service has been pwned, so your service, someone got RCE on your service, right? You still can't like execute RCE. You won't get RCE on the host lah. So your RCE is limited to the container. And if you guys played CTF before, you notice that our CTF challenges, right? We mostly use Docker to host these challenges, because you want this isolation of challenges from one another. So you don't just like, if you solve one challenge, then you solve all the challenges together, right? So that's why you need to isolate the services. And I also talk about the programmatic use of Docker. So later on you'll be learning a bit of Docker file and Docker compose syntax. They're just like text files that you can write, and then you can network them together, and then you just run a command, and then all the containers will spin up. So programmatic. You can also view logs in Docker. So later on you'll be seeing how the logs look like. I mean, it depends from service to service, but you can view logs, and you can also see which services are running on which ports, for example. Yeah, and there's also this idea of the Docker image repository lah. So for example, like if you need an Ubuntu container, right, you don't have to like define the container by itself. You just use the community image, right? Then you just download the image. There's a lot of other images also, like there's one for Python, one for UV, Node.js, yeah. So a lot of images. Okay, so this is the old yes, this is the old network topology that you learned in the first workshop, right? So over here, this is the traditional one. So you see that for example, this guy, he can connect to only through this example.com port 443, right? And then within here, there are internal services that are also running within the network, but these are running not on they're running on separate machines, right? So you can see the internal IP. So what happens here is that your exposed host, right? Your exposed host will communicate with the internal host via their internal IPs. So I mean, for those who know networking, your internal IP is like 172.16 all the way to 32 lah. And then you also have your 192.168 and your 10.0 range. Yeah, so these are running on different hosts, right? But now Docker allows us to run these services on the same host. So what happens in Docker is that now they are running on the same machine as example.com port 443, and you can see now you can access them via the local host binding instead of having it on different hosts. This is Sean. Yeah. Okay, anyway. So over here we can save. You don't need to buy 3 separate machines, right? You can just use the same machine, and you just use Docker to containerize these services so that they don't in the event one is compromised, they don't like all compromise each other lah. And we still need we can still like have like a very similar network topology as the traditional one. Yeah. Okay, so now we look at Docker files and Docker compose. So this is an example of a Docker file. So okay, let's see. Anyone here familiar with Docker files, like how to write Docker files and stuff?
Nobody writes Docker files. Yeah.
Nobody writes Docker files?
I don't write. I just run it.
I see. Anyone else familiar? You're familiar? Alright, can you run me through what this Docker file does?
That's what I meant. That's like we are learning right now.
Okay. Anyone more than slightly? Are you more than slightly?
I did some for CTF infra.
Okay. Then you should be able to tell me what this does.
So like, it's just like, it runs some script on your system, right? Then it copies your main.py into the containers.
Wait. It runs stuff on your system. This one. Oh,
the
line 3 is it?
Yeah.
On your system?
No, the inside.
On the container. Okay.
Then after that, it copies the main.py from your system into the containers slash main.py. And the same thing for templates. Then after that, it runs Python 3 pip install class on the container, and then it Python 3 main.py.
Eureka! Let me give it a sweet. You want White Rabbit or Mentos? White Rabbit,
Why you got so many people?
Because my workshop is popular.
What's that? We only got 8, bro.
Oh, actually?
Yeah.
Oh no, but I think it's correct because
People confused or something.
you check the sheets. Check the sheets.
What sheets?
The Google sheets. You check with registration.
Okay.
But they say they're all wet lah.
Yeah. No, like just by eye power. Yeah, that's all.
Okay. Anyway, so sorry, what's the name? Ping Han.
Oh my god.
It's okay. So Ping Han is absolutely correct. So let's just run through line by line lah. So the first one, this command, this keyword here from is telling us we want to use a pre-built image lah. So here we're using the Ubuntu 22.04 image. We'll be pulling it from the Docker registry. So if you just search like Docker image Ubuntu, and you can see here the Docker hub has the hub has images. So you're using this 22.04, and then okay, so now we have a Ubuntu 22.04 container. Then we can run commands in it. So for those who are using Ubuntu, your package manager is apt-get, right? So you'll be running apt-get update and then install Python 3. So you can see here this nn. I mean, this is just your bash syntax. It's not any special syntax. Yeah. Okay, so between here and here, right, what happens is that Docker will actually cache the intermediate container. So the intermediate image, right? So we start off with the base image, this Ubuntu image. It will cache it. So if another container uses the same image, it doesn't need to download the image again. It's just a small fun fact. Okay, this caching also happens for each of the lines. So over here, line 3, then we run this update, right? Then Docker will create an intermediate image, and this intermediate image will be an Ubuntu 22.04 image with the Python 3 package inside lah. So let's say we run this file again, but then we change like this line. We change here to app.py, for example, like that, right? So if we do this, Docker will be able to remember that, oh, actually there was no change in the previous lines. So from lines 1 to 3, there's no change, right? But line 4, there was a change. So it will use the intermediate image from that it created until line 3. It use that and then continue building a separate image from there. So this caching mechanism is quite useful lah. It reduces your build time by a lot. Okay, then now this add keyword, right? Add is just copying from your system to the container. So your Docker file is in. Will be running from a certain directory, right? So from the current working directory of your host, it will copy it into the container. Same for this one. So this is for files, this is for directories. And then lastly, it will install Flask. And then this command keyword, you always see this command, either command or entry point at the end of a Docker file. For most images lah, you see this command keyword or entry point keyword. So basically this tells Docker that this is the final command that I want to run. It's going to be a long running command. You can imagine like this main.py is running like a Flask server lah, a Flask web server. It's going to be the command that is running in the container. So usually your containers, because they are services, right, they only be running specific services. They won't be running like many services at once. So this is the main service that's running on the container. The difference between command and entry point is not very significant, but you can go and look up. I mean, it's not important for our purposes. You just need to know that there's an entry point and there's a command keyword. Yeah. Yes, okay. If you take a look at the other challenges, right, you see that, I mean the challenges on CTFD, you see that there are some Docker files that are put inside. You can take a look and then see like what the commands are running there in there lah. What the commands are. And then you can see like how the container works. Yeah. Okay. So that was Docker file. Now we have another file called Docker Compose, and Docker Compose is not technically part of Docker. It's an extension of Docker. So Docker is the containerization software, right? But you can build containers and you can network them manually, or you can also use Docker Compose. So Docker Compose does makes your life easier lah. So you don't need to network the containers by yourself, or rather you can just specify it in this YAML format, and then they will do all the networking stuff for you. So over here you see, okay, there's a lot of stuff going on. Under the services keyword, every Docker Compose must have this services keyword lah. So services, all the services are defined under this. You can see by the indentation, right? All these are under services. So each one of this is one container by itself, one container. Okay, let's look at the web container first. So the web container, you see, okay, every container can either have a build keyword like this, or image, if I'm not wrong. Yeah, image, either build or image. In this case it's build, right? So what build does here is that it will look inside the web-service directory. It will look inside for a Docker file, and then it will build the Docker file and then run it. So the Docker file, like for example this Docker file, right? It will build the Docker file and build the image. Then there's another one, ports. So for example, if our previous this container, right, let's say the Flask service is running on port 3000, right, but we don't want it to run on port 3000 on the host. We can just remap the ports here. So the order of mapping, right, is host port colon service port. So the external port colon the internal port. So this web service is going to be running on the host port 443, but in the container is running on port 3000. Yeah. Okay, this depends on, is not that important. Like, basically, if your DB, so if you have another container here, right, if this DB goes down, your web container will also go down. So it won't allow you to access, it won't allow the web container to be alive when the DB container is dead. Yes, and then now the DB container, there's nothing much different lah. It's building from database. Over here with this volumes thing. So usually for your database, you want to be able to have like persistent storage, right? You want to store the DB somewhere. And if you tear down the container and then you delete the container and rebuild it, right? If you don't specify volumes, the container storage, I mean the container, the disk is gone lah, the file system is gone, right? So you need to store the data somewhere else, so that even if you rebuild the container, your data is still there, right? So what this volume does is also host to service. So on the host container, the /data, so from the current directory, the data directory, it will be synchronized with the services /data directory. So this is at the root /data, right? Let me like rename them. This is I call it like, okay, data, and then this like db. Yeah, so the in the current directory, the db directory, right, it will be synchronized with the /data directory. So all the stuff, any file that you put in the containers /data directory will also appear in the /db directory in your host, and vice versa lah. So if you put files in /db, it will appear in the /data. I will do like a small demo of like how this works in a moment, because I think it's a bit abstract right now. But okay, one more thing to note. So you see these names here, right? These names aren't arbitrary. These names, they actually have some significance in Docker Compose, right? So these are the container names. Later on, when I show you the hands-on, you'll see that the container will be named in a certain way based on this name lah, based on the names that you define in Docker Compose. In addition to that, right, Docker Compose will create a network for your containers, like a kind of like a private network for your containers, so that they can communicate with each other. We already talked about this like networking thing earlier on, right? So Docker Compose does it automatically for you. And in here, right, how they assign because you don't want to hardcode the IPs, you want to put host names, right? So that let's say if web wants to talk to DB, it can, you don't need to go and find out what the IP of DB is. You can connect via host names. So Docker Compose will actually use the name that you define here, this name, as the host name. So if web wants to talk to DB, it can just talk to DB on like literally like DB port 5432 for example. And then if DB wants to talk to web, it can talk to web on like web port 443 port 3000. 443 is on the host, right? So web port 3000, just like this. So these names aren't arbitrary. They actually have like some significance lah. I think I will. Yes, I will do a demo of like how this works in a moment. Okay, this is the networking thing I was talking about. So, these IPs here, right? They are technically placeholder IPs, but on most of your systems, if you run it right, it's going to be the same, because your Docker daemon will actually assign the IPs quite predictably, yeah. So okay, there's a lot going on here, but this is your host, okay? This is your host. These are services. So this is the web service. This is the DB service. Your host has an internal Docker IP. So this 127 is your local host, right? 172.17 is your Docker network, okay? So all this is in the Docker network. Your host has a default IP in the Docker network of 172.17.0.1. The only number that can change is this number. This number, depending on which private networks are available, right? It can be 18, 19, 20, etc. So 17 is usually a default, but it can be other numbers also lah. Your host is .0.1. In this order, right? From here, we define the web container first. So the web container will be at 0.2, and the DB container is at 0.3. So they can communicate with each other via these IPs as well. They don't have to use the host names. But since we already mentioned that this number can change, we don't want to hardcode these lah. So we can also use the so you can see here, if we use Docker Compose, right, it will create a custom network for us. We can use the web and the DB host names, so you don't need to care about what this X value is here. So okay, communication with the host is a different story. That one, it depends what system you're running on. Out of scope, you don't need to talk about it. Communication within containers, you can use the host names like this. Yeah. Okay. I'm going to run through the demo first, and actually no. I'll run through the commands that I'll be using in the demo first. Then I will do the demo. Okay. So okay, the first one is Docker build. Docker build just builds the image. So building an image and running an image is different. If you build the image, right, it will just be on your system. It won't be running. You need to run a separate command to run it, right? So build -t web latest source. So you're building from the source, this source directory. You're assigning a tag web latest. -t means tag, yeah. Then afterwards you can use this tag to run it. So docker run web latest -p. So over here I combine two flags together. It's actually -d -p, okay, but it's a shorthand you can use in Linux. So -p port 80 mapping to 3000. So we already mentioned host port mapping to service port, right? So on the host is running on port 80, on the container is running on port 3000, or rather port 80 on the host maps to port 3000 in the container. Okay, and -d just means run in daemonized mode over here. So if you don't specify -d, your container will be running in the foreground lah. But sometimes you want to run it in the background, so you can use -d to specify that. Okay, you can also use Docker Compose up like this. So this one you can only use it if you have the Docker Compose .yaml file defined. So if you don't have a docker compose YAML, right, you can't run docker compose lah. I mean, then you have to do the manual way like this, or you can write a docker compose for yourself if you want. Nothing much to, most of the stuff that you want to configure is in the compose.yaml, so there's nothing much to talk about here. There's the same -d flag. -build just means rebuild the image if there's any changes to the image lah. Okay, then once we build a container and run a container, right, we want to list the containers that are running on our system, all the services. So you can use docker ps. Docker ps will list the, okay, docker ps is an alias for docker container ls, right? And ls is like your Linux ls lah, right? You list containers. So docker ps or docker container ls, it will list all the currently running containers on your system. And if you specify the -a flag, it will also list the containers that stop or like crash or something. Yeah. And then you can also stop a container like this. So later on you'll see that each container has a certain ID associated with it. And the ID is actually a very long like string of alphanumeric characters, but hexadecimal characters. But you can just use like the shorthand ID. So I'll demonstrate this later. It's too abstract here. You can stop a container, then you can remove a container. Okay, then those were for containers. You also have commands for images, very similar. List images, remove images. Yeah, okay. Okay, now I'll do a little bit of hands-on. Honestly, is it big enough? It might be a bit hard to follow, but I have a little hands-on over here that I created. Yeah, originally I wanted to distribute this for you guys to try on your own, like to try writing your own docker compose YAML, but I feel like it's a bit too little guidance. I want to guide you guys through it, and also I couldn't find a good way to like let you guys have a flag to submit without like you guys cheesing the challenge. So I'm just gonna demo in here lah. So we have a front end over here. I'll look at the docker composer. So over here we are pulling from this image, this UV image lah, and then there's this new command here that we haven't learned, work directory. So what this does is it sets the current working directory of all the subsequent commands, right? So everything after this, right, the current working directory will be /app. So if you see, I do copy .. right? So it will just copy everything in here to the /app directory or the current directory. The /app is the current directory, yeah. And then run, and then start your service. Okay. Then we have a database over here. So this database, we are just using the MySQL community image, set some environment variable. So this env is a new command that you haven't seen before. So it just sets a certain environment variable lah. So I think it's quite simple to see. And then we copy this into this init.sql file into this entry point folder here. So you can see that in this Docker file, right, there's no command or entry point keyword at the end of the Docker file. Like the last command you ran is this copy, right? That's cause this MySQL image, right, it has a default entry point. So it's abstracted away from you. You cannot see this in the Docker file. But if you just so if you comment this out, right, like this, so the default service that's going to run is your MySQL service. There will be a MySQL database running in the background. Then if you put this in here, this init.sql, you can put it in this directory. The image is configured such that it will read any files in this directory. It will apply the it will run those files and it will apply the changes to your DB. So you can see I have an init.sql here, and then it will create a table and insert to the table. So it's just a little abstraction that you don't see in the Docker file. It's not very important. Just cool stuff. Okay, so now we have looked at database and front end, right? Just now the database was the MySQL, front end was the UV image. Then we have a Docker Compose here. So as we have seen earlier, we have defined here two services, the web service and the DB service. Both of them are exposed on the host. So this one is exposed on port 80, this is exposed on port 3306. Actually, it's good practice not to expose your database. So, because most of the time your database you shouldn't be able to access your database outside the host. So, if you are security minded, you should delete this. Don't expose your database. So, even if this is deleted, right, this ports field is deleted, your web service can still communicate with your database service, because your Docker Compose already created a network for it, right? So you can still the web container can still access the DB container via DB port 3306 like this. So you actually don't need the ports view. I'm just gonna leave it because I want to demo some stuff, but yes, okay. Let's spin up the containers. So you run this command. Make sure that you run this command in the directory, the current working directory that has the Docker Compose file lah. So you run it, then you can see over here. Actually, all the images are cached already. All the intermediate images are cached. So, and then you can see. So these are the image names that are created. Okay, so the format in which Docker Compose creates your names is like the directory that the image or container is in, followed by the image or container name. Same for network. The network is just the current working directory underscore default. Okay. Then if you run docker ps, you can see the containers are running in here. And this is the container ID I was talking about. So if you, let's say I want to see the logs for the web image, right? Docker logs. I don't have to copy. I can copy the whole ID. Like if I do this, it will show me the logs. But I can just do a shorthand. So if I do 68, it also shows. But if your ID is too short, if I just do docker logs 6. Oh wait, okay, I guess I don't have any other containers running. But if it's too short, right? If Docker cannot differentiate between if there are multiple containers that are starting with 6 like this, right? Then it will ask you to provide a longer ID lah. I guess we can use 6 as the ID. Anyway, that's Docker logs. Then you can also run a shell inside the container. So let's say I need to debug something in the container, right? And do docker exec -it. So -i means interactive, and then -t is the actually I'm not sure what T stands for. What does T stand for? Is it?
means TPY. Attached TPY.
Oh, attached TPY. Yeah. -it. Your image ID, your container ID, followed by the command you want to run. Then you can see here I will spawn a shell inside the container. So if you can see that I'm in the /app directory lah. This /app is the directory that we defined for the web service just now. And then you can see all the files are in here. And oh, there's no PS. Whatever. Okay, anyway, yeah. So that's how you inspect your containers. Then let's say I want to, okay. Let's say I'm in the DB container. Okay, this is the DB container. I want to communicate with the web, right? The web container. I can do so with the web host name that we defined earlier, right? So I hope that's curl. Yes, curl 5000. Yeah, so you can see I'm able to curl the web container lah. If I go to my host, right, go to localhost port 80, this is the same web container that's running in the backend. Okay, and what else can we do? We can also curl from the host, I think. So if we use the hard-coded IP, yes. So earlier I was talking about the hard-coded IP, right? Right now our IP is .17 lah, so we can actually access the host from the service as well via this IP. How I know this is host is because I don't specify a port here, so the default port is port 80, and I know that the container is running on my host port 80, but on my service port 5000. So if I do curl HTTP 172, if I do port 3000, right, I won't be able to connect because it's not running on my host port 3000, and vice versa. If I do HTTP web port 80, I also cannot connect because it's not running on web port 80, it's running on web port 3000. Yeah. Is there anything else? I can kill the containers. Docker stop C668. And you kill the containers like this. It will take a while to kill. Another way you can kill containers also. So let me start them out also. Oh yes, okay. If I don't specify -d, right, this is what happens. It will run in the foreground lah. So I won't be able to access my shell. -d. Okay. Then you can also stop them using docker compose down. Docker compose, you can tear down containers like this also. It will stop the container, and then docker ps. Now containers are gone. Docker ps -a. There's a lot of containers. Yeah. You know what? Let's delete all these containers. Never mind lah. Okay. Anyway, let's say I want to delete this container, right? Docker container rm id, and then if I list the images, I also have a lot of images. Let's say I want to delete this container, then docker image rm id. Yeah. So yeah, that's about it for Docker. Okay, before we move on to SSRF, any further questions about Docker? If you guys need a toilet break, you can have a toilet break. So we will come back at in 6 minutes at 10 AM. Yeah. Okay, let's continue with SSRF, server-side request forgery. So, we have a challenge in CTFD for day 1. Don't know if you guys tried it already. It's about SSRF. So, if you guys already did it, then good for you. But I'll do a walkthrough after this lah. So, in SSRF, right, basically what you can do is you can forge a request from a server to any website of your choice. So I mean that's what the name is lah. Server side request forgery. Yeah. So if your server, for example, like can visit let's say you can download like YouTube videos, right? YouTube downloader can download YouTube videos. So how does it download YouTube videos? It visits youtube.com, right? But if you can trick it to visit something else other than youtube.com, then that's how you can forge request on that YouTube downloader server, right? Yeah, usually in CTF challenges you see that your the service, the vulnerable service, right? It will either accept a URL or like the path for the URL. So you can like exploit how it builds the URL from your path of the URL, or you can, if it just takes in the URL directly, then I guess you don't need to exploit anything. You just put the URL in lah, right? You can play with it. You can see how you can get it to visit other websites other than the one that it's supposed to visit, right? So these are some examples of I'm not saying that they are vulnerable. They could be vulnerable. You can try for yourself. You can basically put in a URL and then it will visit the URL for you, right? But all this depends on what the context of your proxy is also, right? So if your proxy is meant to visit any arbitrary URL, then of course if it's configured correctly, then that's not a vulnerability lah, right? So not all proxies are vulnerable to SSRF, or rather, even if you can make a request, a request to any arbitrary URL from the server, right? It doesn't necessarily mean that these requests are unintended. Like if they are intended, then that's part of how the application works. That's not a vulnerability, right? But the main how do I say, like the main thing you can exploit from SSRF, right, is that if you can visit internal services. So earlier we've covered how Docker works. There are services that are internal, that only the server, let's say the web service, right? Only the web service is allowed to visit the DB service. But if we can use the web service to create our own, to forge our own request to the DB service, right, then we can potentially make requests to the DB that aren't supposed to be made lah. Because by right, all the requests to the DB are all the requests to the database are defined by the developer, right? So they're supposed to be safe requests. But if you can forge your own request to the database via some SSRF vector, then that allows you to, let's say, delete data from the database, or you can even leak people's passwords and stuff like that, right? Leak some data. Yeah. Yes. So over here, you can see this is the YouTube downloader. This is YouTube downloader, youtube.com. So in the normal scenario, your client will tell the server, oh, I want to get youtube.com/video. Okay. So the server itself will take this URL and then it will issue a request to youtube.com to get the actual video that you want, right? So now youtube.com is sending a video to the server, right? And then the server will relay this video back to us. That's in the normal scenario. But if we change this URL over here, change this to something else, so let's say some private API. So let's imagine this server has some private service that external people are not allowed to access, but the server can access, right? We can use this YouTube downloader to make a GET request to this private API, and then the server will just return us whatever was returned from private API, right? So it returns back to us, and then now we can access, let's say, admin creds, for example. Yeah, so this is an example of how you can use SSRF to do stuff you're not supposed to be able to do lah. Because you can see here, there's no direct link from client to private API, because this one is on the private network. You cannot access it from here. But via SSRF, we can actually basically access the private API through the server and then get output like this. Yeah. Okay, so that's great. Okay. SSRF. Where's the SSRF?
You can enable an admin panel.
Oh, okay. Oh, so you disabled it?
I think I did.
Oh, okay. Changes. Yeah. Edit. State.
No pool, no. I'm broke.
Is it?
State is enabled, yeah.
I just put it.
Yeah, correct.
I can do 6 pools right now. Wait.
Okay.
I just need to copy 6 pools. Wonderful. You do the winning 5.
Okay. If you go to web, right, you can see this. There should be this challenge running. Let me see if the service is running. Yes, it's running. So, this simple SSRF. Actually looks like. Oh, actually looks like no one solved it yet. Then, you know what?
I didn't see it yesterday also.
I maybe I was hidden. Anyway, you can give it a try. Since no one has tried it yet, it will become a hands-on instead of a walkthrough. Eureka! So, I'll give you guys maybe 15 minutes to try this one. It should be quite simple. Simple SSRF.
6 star. 5 lah. Oh, you go there. I forgot to put you this. Yeah. I get for you. What? 300. I did 300. What was the PP? Yeah. But then I did 300 for you. So what I hot one? Hot 2? I did 300 for her. For me? Then defender go. So you have to do this. No. So my spot is very good, something like that.
Okay, 15 minutes for this. We will be going through at 10:30. I can give it a shot.
Power must be a power of
Okay, let's start the walkthrough. I see quite a few people saw already, so must have been quite simple for you guys, right? Okay, so if you look inside internal flag service, I already pointed out you need to get the flag from here, right? It's running on localhost port 6767 and at the get flag endpoint, right? So all you need to do is over here, HTTP port 6767 get flag, and then then you get the flag already. So what's happening behind the scenes, right? So I'm going to spin it up locally. I'll just try to talk about this. It's running on port 80.
I mean, if you can do edit this value, then you can especially the edit. So you're making like it's like 8 errors
Oops. Is this the latest?
I
I think this is not the latest.
This is the validation part.
I haven't updated it.
But you wrote it. Anyway, it's okay. Illegal option N. What is this long command?
Oh, wait, I did.
You did, right? Okay, wait, I'll just copy it from the.
So inside the array,
I'll just use this one.
And then they compare with the charter 6 and length. How they.
Oh no,
Something like that.
it's solved.
I mean, I just do this just to verify that
Yeah.
everything's 1 to 1. It doesn't match and it doesn't go through. And then above here is just I guess the input is to meet the size. Meet the criteria.
Let me turn off the music.
Oh, meet the criteria.
Okay, so
People here to help.
over here, right, we have this. So our container is here, lah. I'm going to show you what's going on behind the scenes. So if we launch a shell in the container, then is that else? Oh, it isn't. Okay. Anyway, within the container, right? If we curl, wait, is that PS? Yes. Yes. So you see, there are two services running on our container. There's this internal flag service, and then there's this main.py. This main.py is the one that we are communicating with on port. On the our locals is port 8080, right? But we cannot access the port 6767. So if we try to, we can't access this. Okay, so via the container, right, we can since it is exposed only on the locals interface, not on the 0.0.0.0 interface, right? We can actually curl. We can actually reach it from within the container itself, lah. So if we curl localhost port 6 at the get flag endpoint, then we will be able to get the flag. So that's what's going on behind the scenes. If we put in the same URL, so over here I put 127.0.1. You can also put localhost like this. Then you press go, and you get the flag. Yeah. So that's an example of how you can use SSRF to access internal API endpoints. Yeah. Over here there's some diagrams to walk through, I guess. So the proxy server will request the internal flag server, and then after that you will get the flag from there. Okay, that's all the basic web stuff we're going through today. Now we're going to go straight into cloud. Anyone here doesn't have their AWS account set up yet? Is the debit card issue? Is it? You need a card to. I'm not going to give you a card, but for this first portion, right, you don't need an account yet. We will be needing the account after lunch. So please settle your AWS issues by lunch, lah. I actually sent out a form. I don't know if you guys saw the Discord. There was a form. If you couldn't set up, we could have helped you set up an account, but I guess it's a bit too late to set up now. No, it's okay. You can ask your parents to give you some form of payment method to verify the account. Anyway, right now we'll be going through a bit of. It's going to be a bit of theory lah, because there's a lot of theory that you guys need to know before you can start doing AWS exploitation. So it's going to be a bit dry, but just hang in there with me. Okay, so what is the cloud? So right now we have been running things on our local computers, right? Actually, we can rent computers lah. You don't need to buy computers. So the cloud is just a way for you to rent computers. There's a lot more than just computers you can rent on the cloud. You can, on AWS, there's so many different types of services that it's super complex. And basically our goal in AWS exploitation, right, if we want to exploit misconfigurations or overly permissive permissions granted to us, such that we can access resources that we are not allowed, we are not supposed to be able to access. So because of how complicated an entire AWS ecosystem is, right, there's a lot of little things here and there that we can exploit that people may miss out, that people setting up infrastructure may miss out, right, that we can exploit to get access to certain things. Yeah. In a CDF context, is you get access to flags lah, of course. Yeah, so besides compute, right, you can see here, you cannot see here, but it's too small, but there are a lot of different kinds of services in AWS, right? Compute is only one small section of this entire thing. There's so many different services that you can access. I'm going to make it really big, bigger. And you can see after I zoom in so much, right? This only this very small section of compute here, and under compute we already have so many different services, right? We have EC2. EC2 is our main like the container thing that we've been talking about. We have like Elastic Beanstalk is to run like Docker containers. We have Lambda, serverless functions. We have so many different types of compute, and this is just a small section of the compute section, right? And the compute section is just a small section of all the services on AWS. Here, then we have Kubernetes. If you guys are familiar with Kubernetes. Other stuff, S3 buckets. We'll be going through that today. Even blockchain. Why is that Amazon managed block? I don't know. Yeah, so many things. Let me. It might. Okay. Yes. Just give me a moment. Let me check if the recording is still running. Yes, it is. Okay. Okay. So, as I mentioned earlier, we want to exploit misconfigurations in these like resources, right? So, what are certain types of misconfigurations we can exploit? So, first one is very simply put, is like your Discord roles. They give you too much permissions, right? Then you can see stuff you're not allowed to see. That's a very simple way to put it. And this is the first one, the IAM, overly permissive IAM policies. So if you let's say we assign the Discord rules wrongly, right? Give you permission to see our admin channel. That's an example of an overly permissive role policy lah. Another way we can exploit another way we can get access to resources that we shouldn't have access to is via credential leaks. So this is like if I steal your Discord password, or rather you steal my Discord password, right, or my Discord user token, then you log into my Discord, and then you can see all the admin channels and everything. That's an example of a credential leak lah. And lastly, this list is not exhaustive, but broadly speaking, another way you can get another way you can exploit stuff is via misconfigured resource policy. So, for example, if the admin channel, I allow everyone to view the admin channel, then that's a misconfigured resource policy, right? Which is different from a misconfigured role policy. The role policy was I allowed, let's say, web/cloud B, people with the web/cloud B role to see the admin channel. But misconfigured resource policy is I allow on the admin channel, I set the permission such that everyone can see the admin channel. Slightly different, but the end goal is still the same lah. I want to see the admin channel, right? And I'm not supposed to be allowed to see the admin channel. So there are many other ways to exploit things. This is just like broadly speaking, but this is like the main goals of cloud exploitation lah. Yeah. So today we are only going through a very small section of things. We'll go through IAM users first. The order is slightly wrong. IAM users first, and how we can evaluate like role policies in IAM. IAM stands for Identity Account Management. Yeah. So how we can evaluate these policies and see what resources you have permission to see lah. Then after that we'll go through some resources. So we have S3 buckets. S3 buckets is like a file storage system, kind of like Google Drive. Then we'll look at EC2 instances, which I already mentioned earlier, is your vanilla IaaS, infrastructure as a service. It will give you containers that you can do things inside with. And then lastly, you look at lambdas, which is like a kind of a newer kind of compute, serverless functions, if anyone is familiar with this. We look at some of the things we can exploit in lambdas. So IAM users is like the overall, we'll be using IAM users, like IAM tokens and everything throughout the entire workshop. Then these are the three resources that we're looking at, and we'll be seeing how we can exploit them lah. We'll also be like deploying some of the resources on our own, just to see what things we can configure when we deploy. Because like from an attacker's point of view, right, it's very unclear. It's very difficult for us to see what we are allowed to do. But from a builder's point of view or like a defender's point of view, right, when we deploy stuff, we are able to see, oh, we can configure this and this. So it's very helpful for us to deploy all these things ourselves, to take a look at what we can actually configure lah, just to know what is the environment that we're dealing with. Yeah, so we'll be deploying some of these ourselves. It might cost you a little bit. I guarantee you it won't cost you more than $1 to deploy these things, as long as you remember to take them down like soon enough. And I think like if you sign up for an AWS account, you get like $200 of free credit or something. So you can just use that free credit to deploy all this stuff. Yeah, I mean, if you're not comfortable with spending, or if you are scared that you spend too much, then you don't have to do the deployments lah. But it will be really helpful if you can follow along with when we deploy all this stuff. Yeah. Okay, let's start with IAM users. Actually, it's almost lunchtime, but this session is pretty long. I'll give you guys a little like teaser on what we're going through for IAM users. Then after we come back from lunch, you can go and digest all this information first, and we come back from lunch, we'll look at some walkthroughs. I mean some like example policy evaluations. Okay, so like I mentioned earlier, IAM users is like your Discord role management, right? I don't know if any of you guys are like very big Discord mods. I'm not a big Discord mod, so not very familiar with Discord user management. But basically, you can configure permissions for these users, and then you can issue these tokens to people for them to use, right? When you create an AWS account, your root account, so the account that you log into the AWS console with, right, that is called the root account. The root account, you can generate a IAM key pair for the root account, but AWS will tell you that, oh, actually this is not recommended, because you cannot easily configure permissions for this root IAM user lah. So the root IAM user, it basically has access to your entire account. He can do whatever he wants. He can deploy like 1 million EC2 instances, right? So if your root account IAM token gets leaked, right, then it's GG for your account lah. But it's also like the easiest way to configure your AWS CLI later on when you need to use AWS CLI to do things, right? It's very convenient for you to use the root IAM token. So just make sure that if you do use the root IAM token, make sure that you don't leak it, or if you do leak it, make sure to revoke the token after this. Yeah. Yes. So in addition to that root IAM user, you can also create specific IAM users that only have permission to do certain things. Well, you need to be able to. You need to configure all these permissions yourself, so it's a bit more troublesome, but that is the recommended way for you to create an IAM user lah. Yeah, so okay, I already went through this. This is how an IAM user key pair looks like. So you can see over here long-lived. So this is a long-lived IAM key. Long-lived IAM keys, right, they only come with two values. The first value is the ID of the key. So one thing to note is you see this is AKIA. All long-lived IAM keys, right, start with AKIA. Then there's the access key itself. This is like the password lah. So this is like your username or your user ID, and then this is the password. So later I'll show you how to use. If you have an IAM key, how do you put it into AWS CLI such that you can use these credentials to run commands, to do things in AWS. Yes, and this is a long-lived IAM key. So right now we've only been talking about long-lived IAM keys. There's also short-lived IAM keys, and you can see short-lived. There's this additional session token over here. It's a very long token. This one is for services to spin up. So let's say my internal API, I want to create a IAM user for my service to access some S3 bucket, right? And I only want this access to be available for 30 minutes, for example. So I will use a short-lived IAM key. So this set of tokens, right, is only valid for say 30 minutes, and then it only grants access to the S3 bucket for 30 minutes. So after that 30 minutes, you need to request for a new short-lived IAM key, and then it will generate a new one for you. You can see this one starts with ASIA, right? So earlier the long-lived one was AKIA, short-lived is ASIA. Besides that, everything else is the same. You also have this secret access key. You need both the secret access key and the session token to be able to access the short-lived IAM key, to do things as a short-lived IAM user lah. Yes. One more thing to know, right? For both long-lived and short-lived, right, by default you cannot log into the web console. So you need to do everything via the command line, because basically the console is only for root users logged in lah. There is a permission that you can set on the IAM token such that you can access the web console, but I think that will require you giving a lot of permissions to the IAM key, and then it's basically like giving it like root access lah. Not really, but you have to give a lot of permissions for it to do it, for it to be able to access the web console. Yes. Okay, so this is an example of the AWS CLI. So if you run AWS STS is one of the services in AWS, and then you run get caller identity, right? It's going to give you the user ID, account, and then the ARN of the user that you're running this command as. So a lot of new concepts here, especially ARN, right? What's this ARN thing? We will be going through that later. Basically, this is an example of how you can use the AWS CLI to run commands. Yeah, so the format, the syntax that you'll be using, right, is AWS, and then the service that you want to run, and then the action that you want to run on the service. So, for example, if I want to do okay, if I do AWS help, right, it will list all the services that are available. AWS help. Yes. So over here, available services, right? You can scroll through. All these are the services that are defined in AWS CLI lah. And then the specific one that I'm using is STS. So AWS STS help. And then under AWS STS help, you can see the available commands that you can run under the STS service, security token service. So you can see the one that I ran in the slides, right, is get caller identity. So this returns some info about the caller. Like this. Yeah, so you can see I'm using a root token. So this is the root token, this is the ARN of the root token, and this is the account ID and user ID. Oh, and you can see also, since I'm using a root token, right, the user ID is the same as the account ID. But if you are using an IAM token, you see that the user ID is something else, and then the account ID is also something else. It's not the same, but over here it's the same because it's the root token. Yes. Okay. Okay. So ARN. I mean, you saw in the previous slide there's this ARN thing, right? This very long string. Basically, it's a standardized format in which we can refer to any kind of resource in AWS. So this is the format in which you can expect ARNs to come, and there's actually if you look at the AWS docs, you can see it tells you exactly like what each parameter is lah. So partition most of the time is just AWS, you can see that there's a China region and a US Gulf Cloud region. Most of the time you'll just be dealing with this. So you put this AWS in here. So ARN partition is AWS, and then the specific service that this resource belongs to, and region, we'll go through regions later. Account ID that it belongs to, resource type, resource ID. So if we look at the ARN that we had just now, ARN, the partition AWS, service is IAM, and you see here this is blank because this is region. Yes. So if region is blank, I mean you can have blank fields in this ARN thing lah. Region is blank because there's no specific region for this user. It's a global, is a global thing lah. Then yeah, that's it. That's ARNs lah. Okay, I'll go through a little bit of theory about IAM policies first. Then after that we can break off for lunch. Then we will come back and then we'll do some hands-on for IAM policies. So these policies are the ways in which we can define permissions for our IAM user, right? So there are a lot of kinds of policies. The main ones that we will be dealing with are identity-based policies and resource-based policies. So the identity-based ones is like setting permissions on your Discord roles. So you specifically say, oh, this role you're not allowed to, let's say this role is not allowed to ping at everyone. So that's an identity-based policy. Then in contrast, a resource-based policy is, let's say I have a certain channel, then this channel I don't allow certain users to view this channel. That's a resource-based policy. So those are the main two types of policies that we'll be dealing with. There are actually more over here, a lot more. I think there are like 6 different types. 1, 2, 3, 4, 5, 6, 7, 8, 9 types of policies. These two are the only ones you need to care about lah. Okay, then there's also this thing about managed versus inline policy, right? So a managed policies is only for IAM users. It's only for IAM users. Inline policies is for both resources and IAM users. So a managed policy is basically a predefined policy document that AWS created for us already. This policy document grants the IAM user access to a certain group of resources lah. Let's say I want to grant this IAM user permissions to do all actions on S3 buckets, right? So there is a all actions on S3 buckets managed policy, which AWS already predefined for us. Then you just need to attach that policy to the IAM user, and then he will be able to do anything in S3 buckets, right? Inline policies is more complicated. So if we want to control the permissions more finely, right, we will be using inline policies. Then inline policies, we need to write the JSON policy ourselves. Actually, the web console has a web GUI. You can just like click here, click there, then you can create the inline policy already lah. But basically, you only allow access to certain actions as you define it. So it's a very fine-grained way to control the permissions. We can take a look at what managed policies there are in AWS. Let's go to, yeah, so you see there's a lot of different managed policies. Each of them is relating to a certain scope of access. So let's say let's look for EC2. Or like S3. Okay, EC2 full access. So EC2 full access will allow the IAM user to deploy, create, delete, list EC2 instances. Basically do all actions on EC2 instances lah. Yes, and you can see the JSON policy document here. So later on you'll be learning more about this syntax, right? So this basically allows you to do all actions on EC2 instances on all resources. Yeah, and you can see there's even more stuff below it that is I also don't know what it's doing, but it's doing other stuff. So that's a managed policy. If you don't want to write all that, then we use inline policies. I mean, sorry, if you don't want to write all that, you have to use managed policies. If you want to be more fine-grained in your control of the permissions, then you have to use inline policies. And this is the policy document structure. So earlier on you saw there was the action, right? You saw EC2 : asterisk, that was the action field. This JSON document, it follows a certain structure. Every statement is corresponding to a certain action that you are granting to the user, or a certain group of actions. So back to here, you can see, so the main body is here. Then you have a list of statements. So under statement you have a list of statements. Each statement, you must specify an action and the effect that you want on the action. So you can, effect is just allow or deny lah. So indicate, yeah. Thank you. Yeah. Alright, sorry. So effect is either allow or deny. So if you deny, then you say, oh, this guy cannot do anything on EC2, right? If you allow, then you let him do it. We'll talk more about allow and deny later. Then the last one is resource. So resource is, you can say this guy is allowed to, let's say, delete or let's say list instances only in a certain region, right? So you can say only in US West 2 he can specify, he can list all the EC2 instances. So that's what this resource block is for. Then condition, we'll see this condition block later also. The rest are not so important. SID is like, it's just a description of what the thing does. Don't know if you got any SIDs here. Nope. Never mind, later have. So SID is just like a string to describe what this statement is doing lah, in general. Yeah. Then yeah, so that's basically the JSON, the document structure for policies. Okay, I will go through a few first, just to let you guys see what the policies look like. Then afterwards there will be a few others that you can try on your own. So there's this very helpful simulator thing that AWS has provided for us. So I need to log in. I don't know why there's a dance class going on outside, but let's just ignore them. Okay, anyway, anyone thinks it's too loud? I think it's okay, right? It's not that loud, right? I don't know. Okay, anyway, you ask him to move later. Over here, right, you can basically put in your own policies. You can write your policy, let's say for this guy, give him certain managed policies, or even define your own inline policies for him. Then you can see, you can evaluate this, you can create like certain mock services. Then you can see whether the guy has access to the service or not. Very useful for you to practice like evaluating your own policies lah. Okay, so this is our example policy. This one I took from the AWS website. So anyone can take a guess what this policy does. So just take a moment to read the policy first, then try to see what it's doing. And once if you know, you can raise your hand and give it a shot.
Something like that. I don't know,
Okay, so what your friend has said over here is so what you're saying is that this policy will allow you to see the bucket name, is it? see the bucket name only, or see more than that? So you can see the bucket called bucket name lah. Then you can list bucket, right? List bucket will list the files inside the bucket, and then asterisk object, right? You see this asterisk object, it means you can do any operation regarding objects on all objects or on all resources inside bucket name. Yeah. Mentos or White Rabbit? White Rabbit. Sorry. Alright, so he's quite close. So okay, I really like mention what it does lah. So you can see asterisk object, right, allows you to do all these actions on any object in bucket name. Okay, so let's go through statement by statement. The first statement here, this is very simple. It just list bucket on this resource, which means you can list bucket means you can list the contents of the bucket, right? And it only allows you to list bucket on the bucket called bucket name. Okay. The second statement here allows you to, so you see here bucket slash asterisk, right? So on all objects inside the bucket, on all resources inside this bucket, right, you can perform any of the object actions. So delete, get, put, replicate, restore. Yeah. So basically this one is like allowing you to just use the S3 bucket for whatever you want lah. Right. I think I blocked out the SIDs because they actually tell you what the things do. Yeah. So if I remove it, you can see this is list objects in bucket. So you can list objects in bucket and then all object actions. So SIDs, you can use the SIDs to kind of guess what the statement is doing lah. Okay, another one. This one is regarding EC2s. So you can see here there's this condition block. This condition block is doing something. Yeah, it's doing something. Okay, look. Take some time to read the policy. Then someone can try. Tell me what this policy does. I can try to make it bigger. Oh. Okay, never mind. Shucks. I don't know if you guys saw the answer already, but
Soft IP though. Oh, this is like a firewall IP bar. How many instance though? Feels like a controller. Access control leads.
You wanna try?
Access control leads is it not? But since how many instances there, it don't make sense for it to be an access control lead.
If I deny if condition for a source IP is in that
But the subnet.
subnet lah, everything in the subnet gets blocked lah.
Okay. Okay, so over here he said that basically, so there are two okay, we just ignore the first one. The first one is like let us do the first one first actually. So the first one allows all users to terminate instances in all resources, right? So that's a very permissive policy. But now we have a second policy that does a deny. Okay? And this deny has a condition. So it will deny on the condition that your IP address is not in this list. So if your IP address is and you can see this one is the subnet lah. So in this 192.0.2 subnet and 203.0.113 subnet, if your IP address does not belong to this list of IPs, you are not allowed to terminate instances. So there's a lot of nots here, right? Not. Basically all it does is it only allows people in these subnets to terminate instances. Yeah. So there's a not here, there's a not here, and then yeah, it's a bit confusing. But so the reason why we need two statements for this, right? Why can't we just say allow IP address Actually, I also don't know. But a deny statement will override an allow statement. So a deny statement has higher priority over an allow statement. And you'll see that later on when we have multiple policies working together, right? You can see the deny statement is stronger than the allow statement. But if there is no explicit allow statement, right, then you, by default, you are denied also. So there's an implicit deny, there's an explicit allow, and then there's an explicit deny. So this explicit allow initially allows everyone to terminate all EC2 instances owned by this guy, right? But the explicit deny further scopes that limits that scope, further limits that scope to only allow people within these subnets to actually terminate instances. So it denies everyone else that is not in this subnet from terminating instances. Yeah. Fire a bit.
Don't need.
No need. Need it, bro.
I don't use it. All good.
If you insist. Yeah, so it only allows the attached user to terminate instances when he is from these source IPs. So I guess this will be useful if like you're in some corporate environment, then all your developers are only coming from these IPs, right? So you won't want to allow people from outside your corporate network from you won't want to allow them to terminate your EC2 instances. So you only want the developers to be able to do it, right? So even if your IAM token gets leaked, right, if they cannot come into your office building and access your network, right, they won't be able to, at least they won't be able to shut down your entire website or something lah, your entire business, right? I think there's one more. Oh, it's a resource based. Okay, we can look at some resource based ones also. So earlier, the first two we've been looking at, right, these are identity based policies. So these are attached to users, right? Now you'll see a resource based policy. It's a bit small. If you can't see, those people there you can't see, you can look at the TV also. Or if you want, you can come forward and see also lah. Take a look at this policy. Is a bit complicated, a lot of things going on. Try to see if you can evaluate the policy and figure out what it's doing. And this policy is attached to this this bucket lah, just for context. Take a few moments to evaluate the policy in your head. Then if you are super sure that you know what it does, then you can, I mean, don't need to be super sure lah. I won't kill you. Is it? Because I got a bottle. Yeah.
Does it restrict access to
Restrict access to bucket/public. Okay, that's close, but what kind of access? So we need to see what is the action that he's allowed to do, right? And put object. But we also have this, the earlier statement allow put object on all here, right? And then deny from public. So how do these two work in tandem to?
the string is public.
Okay, so your friend over there is quite close. Quite close. So basically, these two policies is like the previous ones, right? There's an allow. After that, there's another deny. It's on it's not on the same resource, right? This one is on the entire all objects inside this demo source bucket. So all resources in here, right? you are allowed to perform the put object operation. Put object is just you can upload an object into that destination lah, right? But then there is an additional deny. This deny stops this user, this Dave user. Just now was also on Dave user. Then this deny stops the Dave user from doing put object so he cannot do put object into this bucket if the copy source is public /star. Okay, so put object, later on when we do S3 buckets, right, you see that put object you can actually do, you can put objects from your local file system onto the S3 bucket, or you can also put object from another S3 bucket into the target S3 bucket, right? So this copy source, right, is only applicable when the source is another S3 bucket. So you can see here, if you are copying where string not like this, right? So if you are not copying from / public into resource, then you are not allowed to put objects in there. So it means that this Dave user can only copy objects from the public, so bucket / public everything into bucket / asterisk, but he cannot upload his own objects because, as we said earlier, an explicit deny takes precedence over an explicit allow. So this explicit allow initially allowed him to put anything into the source bucket, right? But this deny says that if the copy source is not public /star, then he is not allowed to do it. So yeah, this first one is mapping here, and then this one is mapping here. So the overall effect is that the Dave user can only copy from /public into anywhere in the bucket. Not really sure what the intent of this resource is, but you can see the SIDs here lah. Cross account permission to user in your own account. Deny your user permission to upload object if copy source is not bucket prefix. Yeah. Okay, one last one, and then we go for lunch. One last one. This one is about lambdas. So later on we'll be looking at lambdas also. It's attached to the my function lambda. So this lambda over here. Take a look and forgot to give you a. You want white rabbit again?
Yes.
Okay, take a look. This one should be simpler, I think. Anyone has any ideas? Okay, anyone? Okay.
Is it not just like allowing certain AWS accounts to invoke a function?
Not just an account.
I think it's allowed the S3 service to call the Lambda function. Then
Yeah.
for the function, it's under the resources, they specific the function over there, like what function they are calling.
Yeah.
Then after that, string equal. I think for the AWS source account, it's like if the S3 is under this account, then they allow, right?
Yep.
Yeah.
Exactly right. Hey, both of you get a white rabbit. You want white rabbit? Oh. Hey, this one is a bit deformed. Mutated white rabbit. Okay. Okay, so he explained it like perfectly lah. So basically what's happening here is that we see there's a lot of conditions, two conditions. First condition is source account is 1 2 3 4 5 6 7 8 9 0 1 2, and the second account is the second condition is ARN like, and then the source ARN is like this lah, right? So the resource that we are specifying is the my function lambda, and the action that we are allowing is invoke function, and you can see here the principal is the S3 service. Earlier we saw principal is a specific user, right? Now we can also say principal is a service. So what this does is it allows the S3 bucket named Amazon S3 demo bucket owned by the user with this user ID to, so it allows this S3 bucket, right, to invoke my function. So example use case for this is like, for example, if you want to execute a certain action when someone uploads a file. So when you upload a file, let's say you want to, I don't know, email the guy, say your file has been uploaded successfully. So you can make your S3 bucket run certain functions, right? You can make the S3 bucket run this lambda function so that it can do it automatically. You don't need to get a user to do this, to invoke this function manually lah. So you can configure your S3 bucket to do this invoking of the function automatically. So in this case, you only allow my function to be invoked by an S3 bucket named Amazon S3 demo bucket owned by this user. You only allow this bucket to invoke this function and no one else. So if I try to the dance is getting quite intense. It's okay, we're going for lunch soon. With only this policy, right, if there's no other policy granting me permission to invoke this function, even a regular user trying to, even if the owner tried to invoke this function, right, but if he doesn't have permission, he cannot invoke this function. Only the S3 bucket can do it. Yeah. Okay, the next few I'm going to leave you guys to think about these policies for a while. We have more policies that you can evaluate later as well. Now I think lunch should be ready already. So if we can make it past the dancing people just downstairs, you can go for lunch. Wait, before we go for lunch, any questions so far? Yes, you can go toilet.
What is the unlike for the last one?
RN like. I don't know why they use like versus equals. Like there's also an ARN equals, right? But
Only that part I don't really get.
yeah, I think maybe like so if your source ARN, because if the ARN is like it's a certain object in the ARN, right, then it will be slash something. So I think ARN like says that like you have to put the asterisk lah. You don't have to put asterisk lah. But you can also do equals. About the same thing. Any other questions?
Oh, you mean you see?
Yes. There is also a way to do OR, but right now the conditions are at. Yeah, we haven't seen OR yet. Yeah.
You know how RFA works?
What rules on this? Can you run?
Inside the Spotify thing.
I think so. I'm not sure.
If not, you guys can follow me down for lunch. We guys had an okay lunch. The food, we thought the food would be nicer than last week. It wasn't really. I don't know. At least it was like pudding, I guess. Wait. Let's do a recap of the IAM policies and stuff. So I have 3 more policies here. You just need to tell me, can this so this policy is attached to a certain IAM user. Can he access test bucket / flag.txt? Okay, you know what? Let's see how many biscuits we have. Okay. If you answer, so there are three after this. Okay. I mean, there's 3 of these. There are 2 after these. If you answer all 3, right, all 3 biscuits are yours. But you don't know the other 2. You have to. It's all or nothing.
What's the difference? What just statement 1? What is statement 2?
AI says it doesn't have a it's a 50%.
It's like 50%.
Yes.
No.
Yes.
Cannot see.
Yes and no.
Yes.
Okay, so this guy says yes. He says no. Explain your answers. Starting with yes.
Just say you spin a wheel. Allow.
Yes.
Okay.
But that's statement 2.
How about you?
Explicit deny is over explicit allow.
Yeah, what is
Yeah,
denied?
he's in front. Are you
Eureka!
No. Allow.
So
Above.
no. Okay, the order doesn't matter.
Explicit denies.
Yeah. So okay, early on we saw another case of this, right? Actually we saw, okay, for example this one, right? We have an explicit allow and explicit deny, right? The explicit allow, the explicit deny takes precedence over the explicit allow, right? So the order is explicit deny over explicit allow over implicit deny. So implicit deny just being you don't have a policy for it lah. So by default, if you have no policy for it, it will be denied. You cannot perform the action, right? So the order doesn't matter. Earlier the allow was over the deny, now the deny is over the allow, right? But it doesn't matter. The order doesn't matter. We just think about whether it's an explicit deny or allow. So in this case, test bucket flag.txt has this guy has 2 statements lah. The first statement says that he is not allowed to view flag.txt. Second statement says he's allowed to view, but the explicit deny takes precedence. Okay. Yeah, you can see here. Either way, yeah, the order doesn't matter lah. Okay, next one. Since you already answered, you can ask a friend for help, or you can.
Do I get white rabbit?
You want white rabbit over the biscuit?
Yes.
Sure. But only after all 3 have been answered.
What?
Someone joined the Discord call. Who joined the Discord call?
So can this user view his own, so IAM list policies and get policy, basically you can view your own JSON policies lah. Can he view the IAM policies attached to him? So for example, if I'm like some test user, right, I want to see the contents of this policy, right? I want to see this policy itself. There is a permission that you can set to allow people to see or not see your own policy. So if I wanted to see this, can I see it? And this A.WS username is a like variable lah. It will be replaced with the username of the guy that is attached to it. Okay, who says yes? Raise your hand. So, are you raising your hand?
Somewhat.
Okay. Some people saying yes. Who says no?
Blah is my I do to appreciate.
Who says syntax error. Hey, you need to get someone to answer, you know. If not, you don't get your white rabbit, you know. If you don't get all three correct, there's no white rabbit, you know.
I need all three correct.
You can get someone to answer for you.
Can I have like a third of a white rabbit?
How's that work?
You just like cut it, you know.
I also eat the
This
other
economy, too much.
And then
Way too much in this economy.
I can split a white rabbit with someone.
Pack it up, bro. Can Can? Hey, the guy shaking his head. Why are you shaking your head? Do you disagree with them? Yeah. Oh, okay. So you also agree with them? Can see. Are you absolutely sure? Are you absolutely sure you can see?
Maybe he says so. Maybe he says we're all wrong.
Are you very sure?
Don't get out of his brain.
Stop gaslighting us.
This guy just gaslighting.
No, I'm not. You can't. You can't see it. So the keyword here is manage IM policies. So it's a very tricky thing. Okay, for managed policies, right? Only managed policies. Inline policies is different. Okay, for managed policies, they have a certain version associated with them. So you can have the same name for managed policy, but it's a different version and hence a different inline policy, different like policy document. So in AWS, right, this get policy action only allows you to see the version ID. It doesn't allow you to see the specific document in the policy, right? The action that you need to be able to see the policy itself is get policy version. Okay, this only applies for managed IM policies, because for inline policies there is no concept of versions, because there is no name associated with basically you don't need to version something that has no name associated with it lah, right? But if it has a name, right, let's say V1 allows me to see all buckets and then V2 doesn't allow me to see like half the buckets, right? Then that's why you need to be able to get a specific version of the policy. So yes, you need the get policy version permission. Okay, you'll be seeing this later as well if you have time. There's this hands-on that deals with this. I'm very sorry to say that your white rabbit is.
Just give me 1/3.
Who wants to share 1/3 of a white rabbit with him?
Thank you.
Okay lah, I'll give you. But we have one more. Okay, if you can get this one correct, then. So back to buckets, right? Can he view the object and download the object and view the object at testbucket/flag.txt. Is that allowed?
So what, are you gonna say no? No. Very sort of gaslighting us, and then he's actually yes.
I don't gaslight people, man.
I say no.
You say no.
Yeah.
Anyone says no?
I say yes, so like you can split the switch. I don't want to say yes, right? So right, you take half the strap to the other. No, I'll take the whole thing.
Anyone else says no? You say no? Okay. Okay, then anyone says yes? Alright, okay, why no?
You should expect the unexpected.
Expect the unexpected.
Question 1 was no, question 2 was no, therefore question 3 shall go.
It's a pattern than this. So by reverse psychology. This is computer science, not psychology, bro. Wrong course.
Yeah.
Why is it typing? Is it your keyboard, man?
You gotta learn how to use it. I'm not used to going back to 60.
Okay. Yes.
$175.
Okay, but you say no, right? So why?
Cause expect
Expect the unexpected. Well, the unexpected is truly expected. It is no. Anyone take a look at the policy again and tell me why it's no.
He got all.
You got all?
Blue guy.
Hey, but you never raise your hand. Okay, if you can tell me why no, I'll give it to you.
it's the wrong date format. Yeah, bro, you submit like 17, 10. Standing 170. Good luck.
He did it randomly.
That's not
eligible. He got the correct.
Nah. So that's the answer. You did it randomly. Then I'll give you a random seat.
Give me a seat.
Tom's the guy that expected the unexpected.
I'll give him an unexpected seat.
Sounds like no seat.
White rabbit, white
You want a
rabbit.
biscuit?
What do I get?
You're not getting a biscuit.
White rabbit, white rabbit.
Expected unexpected.
Okay, you also answered. I'll give you an expected seat. Share with him. And one for you. Who else answered? No, you did.
Then that's wrong, bro.
That's wrong. Okay.
Expect unexpected or expected.
Okay. So if you take a look at the resource, right? The resource is pointing to test bucket.
The bucket is wrong. Tesla. Is it there's no like stress like
Exactly.
That's why I told you.
Exactly.
I told you go fight.
So earlier on we saw policies where there's an asterisk, right? So if there's an asterisk, it allows you to view all files, all objects in the S3 bucket. But in this case, there's no asterisk, so it allows you to perform get object only on the bucket itself, and it's not valid, right? So you need a slash. The wrapper is S.
I never done this before. It's the other rapper. It's just how it's made.
Okay. Lock in. Okay, so over here there is no slash asterisk, right? So it means that you can only perform, or rather this policy only applies to test bucket and not the items inside test bucket. Okay. Everything else is correct. It's only this thing.
I'll question my life.
Okay.
Singapore, Asia Pacific, Southeast Asia.
Okay, seems like you guys know AWS regions already. Can you guys give me some examples of?
Singapore West, Asia Pacific, Southeast Asia.
US West, US Central.
No, there's no US Central. US they go by state.
Singapore and Sydney.
Pyongyang, North
Sorry?
Korea.
Singapore and Sydney.
Singapore and city?
Never get censored.
Oh wait, then there's Israel. There's Korea.
There's no Israel.
Dubai.
Oh wait, yeah,
North Korea.
Dubai. Then there's Norway.
Okay, those are the countries, right? What are the region names?
Sydney.
Singapore dash West. Asia Pacific.
Yes, Asia Pacific is one, but that's not the full name. I mean, like there are.
Is it not Asia Pacific?
Sorry,
AP South AP.
North America.
Southeast, like AP Southeast. Yeah. That's example. Yeah, AP Southeast. Right? Okay lah. Euro has. Okay, so regions are basically you need to remember that underlying all the AWS resources, right, is still physical computers lah, physical data centers, right? And for AWS, how they segregate them is basically by region. So the physical data center, there are physical data centers which are like groups of computers together, right, in several regions. And within each region, there's also a concept of this thing. There's this concept of an availability zone, AZ for short. So each AZ is a cluster, is a data center cluster. Some regions only have one AZ, some have more than one. So you need to take note of this AZ thing for certain services. Okay.
Hosting in Singapore, always deploy a server in America. Because Singapore has no free stuff left.
So the significance of regions, right, is that for certain services you won't be able to share resources between regions, because let's say you deploy an instance in US West 2, right? Your instance is physically in US West 2 lah. It cannot be in AP Southeast 1 also. So that's the concept of the region. And then there are certain other stuff, like let's say you take snapshots, right? Snapshots are only specific to the region and the availability zone. So if you create a volume from the snapshot and then you want to attach to an EC2 instance in another region or another AZ, right? No, you can't do that. So it has to be in the same AZ. Okay? When you are deploying resources, you need to take note of this. When you are trying to exploit things, you also need to make sure that the thing that you are exploiting is in the correct or in the same region as any resources that is spin up to exploit them lah.
Should always DDoS them so they record $10 million AWS.
There goes the Bloodhound.
Yeah, so these are some examples of AWS regions.
W Bloodhound.
Okay lah, it's not that important, but
They go by state.
Yeah, you do or you do it. Why is it on your VM?
yeah, and for Singapore, if you want to deploy things in Singapore, right, it's over here, AP Southeast 1.
The Singapore West.
You download everything back.
Is there? I'm not sure. Anyway.
Yeah, I mean we all do, but like.
Okay. We've been talking a lot about S3 buckets, right? But we have never actually seen an S3 bucket in detail. Okay. Okay, so an S3 bucket is basically it's like your Google Drive, right? Basically, you can host files on an S3 bucket, right? You can put files inside, and then you can configure who can access the files, who can upload files, and so on. Okay. There's also this special, or rather, like legacy feature of S3 buckets, where you can use S3 buckets to host static website. So like you can put like index or HTML, right? And then if you allow people, anonymous users, to visit the website, then basically it's just like you just render the HTML lah in your browser. Yeah. If you guys have used Python's HTTP server before, right, it's also quite similar. So I can actually spin up a HTTP server now. It looks the same. Okay, let's say I'm in here, right? So you can see in a Python HTTP server, you can see you have like a directory listing. Then you can go to different files, can view the file, you download the file, and go to the different directories. A bucket is similar like this also. You will see some examples of buckets later. Yeah. Sorry, was someone asking a question just now? No? Okay. Okay. So earlier when we were looking at IAM policies, right, we saw a lot of different policies that had to do with restricting our access to different resources in the S3 bucket, right? So this access system is actually quite complicated lah. There's a lot of different permissions that we can set on this. So I'll skip this first. I want to talk about the permissions. Never mind. There's too many. Okay. Anyway, we will talk about permissions later. But okay, each file, each object in a bucket, right, is basically corresponding to a file, right? Each object can also hold certain metadata. I don't know if I have a screenshot of it. No, I don't. It can hold metadata, and like it's basically like your file on your file system lah. And it's specified by a certain path or a certain key. Yeah. So for example, like just now, flag.txt is a key that is linking to a certain S3 bucket, S3 object. Okay. So here are some S3 commands that you can run. So like your Linux directories, right? You can do ls to list. Okay, ls in a bucket to list all the files in the bucket, right? And if you just run ls with no arguments, it will list. It's a special action. The action is list all my buckets, right? So it will list all the buckets owned by the account. You can also move and copy, where source and destination can be. Source and destination can be either local files and directories or S3 files and directories. I mean, except for like local and local. So it can be S3 and local, S3, S3, but not local. Okay, and you can also specify the dash. So for those who are familiar with Linux commands, right, if you put a dash, it usually refers to standard in or standard out. So in this case, you can copy to standard out. I'm not sure, I haven't tried before, but I think if you put dash in source, then you can copy from standard in into a certain destination. Yeah. And then you can also do sync. So if you sync directory, you sync the entire contents of the S3 bucket or the directory that is specified in the S3 bucket to your local directory lah. Or vice versa, you can also sync a local directory to S3 bucket. Okay. RM does what you expect RM to do. You delete the specified file. I didn't put argument here, but you delete the specified object lah. And then there's this thing called pre-sign URL. So this is a bit of an advanced topic. It's not, we won't be using it today, but basically sometimes you want to configure, for example, like earlier I talked about the short-lived access keys, right? So for short-lived access keys, you need to program the service or your web server or whatever to generate these pre-signed these short-lived access keys, right? Well, S3 has a built-in feature for it, so you can create a pre-signed URL to allow. So if you send this URL to someone, that someone will be able to download only that file, and he cannot modify the URL to download anything else, right? It can also be short-lived. It depends how you generate the URL. The URL can have an expiry date, so it means that this guy can only download this file within a certain period of time. And if I'm not wrong, you can also specify like how many times this URL can be used, if I'm not wrong. Yeah, and yeah, there's quite a bit of stuff you can do with it. So basically it's a way for you to kind of give people anonymous access to your object lah, to a certain object in an S3 bucket. Okay, there's also S3 API commands. So if you look at AWS, right, if you look at if you search for S3, you see there's one service called S3 and then there's one called S3 API. So S3 is like a higher level wrapper over the API, and the S3 API allows you to call the API directly. It's not very, it's just like for FYI lah. We'll just be using S3 because don't need to do any special things with S3 API. Okay. So let's say we have this object, right, in this bucket I.YCEP 26. How would the ARN for this object look like, for this resource? How should I do this? Okay, I will. how should I do this? Okay, for each one, right, I'm going to read through each of these, right, and then you tell me what I need to put for each one. So like partition, okay, partition I'll give it to you is AWS. Then what I put for service?
S3.
Okay, S3. Then region.
Singapore or CY
Okay, Shiva is saying depends what region you put. Let's carry on. We'll get back to that later. Account ID.
AWS account.
Okay. Then resource type.
AWS bucket.
Yes. So the bucket name I.YCEP 26, and then resource ID should be easy lah. Example / object. Okay. Let's circle back to region, right? Okay, this is the answer. Okay. You see here, I didn't specify region, I didn't specify account ID. So you can see these two fields are blank. Let's look at account ID first. Okay, so account ID is not necessary to specify an account ID. Only if your bucket name is if your bucket name is unique. Okay. So there's a very long history regarding S3 buckets, which we will be going to. I mean, we won't really be going to it, but it's kind of relevant to our workshop lah. So S3 buckets are is one of the earliest AWS like resources that was defined. At that point in time, right, there was no concept of regions, or rather the regions thing wasn't a very well defined concept in AWS lah. So okay, that's also why there's no region specified for the bucket, because buckets can be global, and in fact buckets by default are in a global namespace and not in a regional namespace. So there is no concept of regions for global buckets, and this is the default kind of bucket that when you create a bucket in AWS, right, the default bucket that you create is a global bucket. Okay, what this also means is that the bucket name must be unique globally. So if someone else already used I.YCEP 26, right, I cannot use I.YCEP 26 as my bucket name anymore in the global namespace. And because of that, I don't need an account ID to specify my bucket, because this bucket name alone, or the resource type, right, this bucket name is unique across the entire AWS, like the global AWS partition. Okay, this global is referring to the partition. Okay, so I don't need an account ID to uniquely identify this I.YCEP 26 bucket. Now, of course, as more people started using AWS, there was a need to create non-global buckets lah. So now there is a new kind of bucket which is not global in nature. We'll be looking at it later, but not in very much detail lah. Hey, so this is the ARN for this bucket. Okay, yes. So this is about the global namespace. The thing about buckets, right, is also, as we mentioned earlier, it's not possible, or is kind of infeasible for AWS to implement a global service, right, because the physical data centers are separated. So how AWS does this, I mean, of course you can sync the state across different regions. How AWS chose to do it is they implement it in a certain region, and then if you request the wrong region, they will redirect your request to the correct region automatically. And this is only possible for S3 because of the global namespace. So if you are talking about other kinds of resources like EC2, there's no such concept of, I mean, yeah, you need to specify the correct region in order to access the instance. Yeah, but the bucket itself is still implemented in a certain region. It's just that AWS abstract away this regional implementation from us and create this global namespace. Again, this is like a legacy thing from the history of S3 buckets lah. Okay, this was the screenshot I was looking for S3 object metadata. It's a bunch of metadata that you can store in an object. It's not very important to know this stuff, but there are some challenges that I've done before that have something to do with these metadata. It's like your file metadata when you're doing like those like forensics challenges. It's similar lah, similar. Okay. There is another form of permission system in S3 buckets as well. Besides the resource-based policy that we've been looking at, right? There's also this thing called ACLs, Access Control List, and it's a very old system that is a very old and simple access system lah. Like later on you'll see what you are able to define in this access system, right? It's very limited and very primitive, but AWS still supports it because it's a legacy system, but they recommend you not to use it anymore lah. For ACLs, the unique thing about ACLs is that you can attach them to specific objects inside the bucket, but resource-based policies, you can only attach it to the bucket itself, right? So you can specify a certain resource, a certain object inside the policy, which the policy will apply to, but the policy itself is still attached only to the bucket and not to a specific object in the bucket. For ACLs, you can attach it directly to the object. Okay. And this is what you can define in ACLs. These are the only permissions you can define in ACL. Read, write, read the ACL, write the ACL, and a combination of all of them. So full control is just the entire thing. So only 5 actions, and in fact the last action is like is just the last action is just a combination of all the 4 previous ones. So when they are granted on different stuff, right, it does different things also. So for example, read, when you're able to read an entire bucket, right, you can list the objects in the bucket. But when you grant read on an object, you can only, I'm not really sure, I don't think you can list, let's say it's a directory, right, you cannot list the contents of the directory, but you can basically read the, if it's an object, you can download the object lah. I'll need to check again if you can access a directory. I'm not very sure about this. And of course you can see the object metadata. Okay, for write, I don't know why is it not applicable for an object. I'm not very sure about this, but for a bucket, if you have a write permission on a bucket, right, then you can basically modify objects in the bucket lah. I guess for objects, this permission for an object is already implemented in write for a bucket, right? So maybe that's why they say here it's not applicable lah. I'm not very sure. Then for read ACP and write ACP is very similar for both of them. Basically you can view the ACL for the bucket or the object, and you can modify the ACL for the bucket or the object. Like this permission is like basically useless, because if you can modify the permission, then you just modify to have full control lah. And like it's basically giving them full control. So kind of useless also. Yeah. Okay. So look at some ACLs. It's very small, but I will have certain slides that will zoom in on certain things. But you can see the overall structure. This is an XML document, not a JSON document, right? So in the XML document, this is over here, the first field in the ACP, in the ACL. This one is the owner. This one specifies the owner of the bucket. So the owner is by default, right? The owner is given full control over the entire bucket. But you can also actually remove this from the ACL. Then you can I guess don't give the owner full control. I don't know. Yes. So in order for the ACL to know who the owner is, right, you need to specify the owner ID over here lah. So in the ACL, the owner ID is specified in this field here. Yes. Okay. The canonical user ID, right? If you check your AWS account, it's different from the account ID that we use in your resource-based policies and identity-based policies. this canonical user ID, you can take a look at your AWS account. There is a different it's a different value lah. It's a different field. Again, it's a legacy thing. A lot of legacy stuff in ACLs. I don't think many other resources use canonical user ID. Yeah, okay. Then similarly over here, the next two fields, it's a bit small. I'm going to expand the box so you can see.
Oh yeah, I got business. That's why I should double the.
Okay, so the next two fields, right? They are granting. So the first one, it grants user 1 write permissions, so he can write to the entire bucket, and the second one grants user 2 only read permissions. But user 1 cannot read. So user 1 can write, cannot read. User 2 can read, cannot write. And by the way, this ACL is attached to a certain bucket, right? So it's not explicitly stated in the ACL. Oh, it's attached to a bucket, right? You need to do that for resource-based policy. So over here, the ACL itself is already attached to a certain bucket. So all these permissions are referring to the bucket permissions. And for ACL, there's also this special concept of a group. Let me zoom in as well. Okay, so there's also this concept of a group. There are only 3 groups defined for this ACL system. Again, another legacy thing, but basically, first group is all users, so just everyone lah. Then there's log delivery, which is a special one, special group for. Actually, I'm not sure what it's for also. There's a third group. Yes, here. There's a third group, authenticated users group. So it's similar to the all users one, just that you have to have an AWS account in order to access this. I don't think you can define your own groups. I'm not very sure about this, but yeah, these are the predefined groups lah. So authenticated users, all users, and then this special log delivery group. This one usually is set by default so that you can I guess log stuff. Let me revert the changes. Okay, so that's about it for ACLs. Basically, it's a different permission system from IAM lah, from your IAM JSON document policy. So how does ACL interact with IAM? Because there are 2 different permission systems going on here, right? So what if there's a conflict? So ACL, right, you've seen here that ACL can only allow, but IAM JSON policies can allow or deny. So conflict can occur if your ACL says, oh, I allow the user to see this resource, but the IAM JSON policy says it doesn't allow, right? So if there's a conflict between the two, right, the explicit deny takes precedence over the explicit allow. So technically you can say that IAM JSON policies have precedence over ACLs. If the IAM policy has a deny lah, right, so it has a deny here, it will take precedence over the ACL. If the IAM policy has an explicit allow and the ACL doesn't say anything, then that is an explicit allow taking precedence over an implicit deny. So also the IAM policy will take precedence over the ACL. I mean, I guess if this happens, then like what's the point of using ACLs, right? So just like don't use ACLs lah. Just use IAM policies instead. It's easier to like use one system instead of having to maintain 2 different systems also.
So ACL not used like now already?
It is still used. Yes, ACLs are still used, but I mean there are always people that are too lazy to change lah, too lazy to implement IAM stuff. Yeah. Okay. Okay. Who still doesn't have their AWS account set up?
Set up is like what?
As in, just create the account.
Oh, wait, yeah, I have my
Okay.
air credit card.
Can you share with your friend? Does your friend have? You have, right? Can you just share with him during the walkthrough? Anyone else don't have AWS account?
We just sign up, just like
I think I
Yeah, just sign up and then but there's a payment. I mean, you need to put in a valid payment method.
Oh, yes, yeah.
Yeah. Anyway,
I just did the.
okay. So we'll just be going through the process of deploying our own bucket lah.
I
So
think I can pass.
just to see what options are available to us, and then we can also play around the bucket and upload our own files into
Okay, I
it.
think you die at the first.
So
I don't
Okay.
think the first is
What is it, stars?
yeah.
Wow, I feel like 7.
sorry.
This is like 6 bro.
Yes.
Oh, 7. Oh, yeah, that's half. Oh, it's triangle. Oh, yeah, this is definitely 7.
Okay. So once you log in already, right, you can see you'll be in like this console. Actually,
It's so
you'll be like here lah. Okay.
maybe never.
You use relax to try it.
If you click on this squares thing, right? Let me zoom in.
Just relax and aim. You just see the movement, you see the step.
If you click on this squares thing, you list all. There'll be like a list of categories, different services that you can deploy. If you scroll down to storage, S3, then you click on it.
And then like 1/4.
Then you can start to deploy your own buckets.
I think I missed that.
You need twice a week. Wrap it up.
No, I missed twice already.
Yeah, I'll just go through quickly because it's not too important that you deploy your own bucket, but just to show you what options there are available lah. So if you click on create bucket, so you can see here, general purpose. This is the global. It doesn't say here global and sorry. This is the global and account, the regional thing says one. This one is limited by availability zone. I'm not very familiar with this directory based bucket also, but for the most part, most of the buckets that you see are these ones, are the general purpose ones. Okay, so you can configure either this one or this one. Then you see you need to choose an availability zone, so you have to choose one of these. And also, since it's restricted by AZ, right, it's also going to be restricted by region. So if you choose this one, you need to be aware of your region. Right now I'm in US, so US West, right? So I can only deploy this bucket in a certain AZ in the US West 2 region. Yes. Okay. General purpose. Then you can also specify this one. Honestly, I haven't really seen any regional buckets before. I only seen global buckets, but let's go with global. Then you can specify a name. Yeah. And then you see here, now if you scroll down, right, there's this part where you can disable ACLs. Or you can enable ACLs rather. It's disabled by default. You can enable if you want to play around with ACLs. Then you can specify stuff here lah. But I'll just leave it disabled. And then okay. If you want, you can take a look at the other stuff also. If not, then you can just go ahead and click on create bucket. Okay, so now I have this bucket, I.YCEP 26. Then I can upload things to the bucket, but I want to use the CLI to do this instead, because it will be useful for us to practice the commands lah. Okay, so how do you configure your CLI? Because I think you may not have been I didn't task you to configure them, right? So how do you configure? You go to over here under security credentials. Okay, security credentials. Then there will be a place where you can create access key. Yeah. So when you create access key, this one will be created for your you create for your root user lah. So you create access key. I'm not gonna click it because if I click it, it will show the access key and then all of you can log into my account. But you can go ahead and click it. Then once you have the key ID and the secret key, right, you copy that and then you paste it into your. So you create a file in your WSL or whatever system you're using. Go to /home/.aws, and then under credentials, right, you put your credentials inside. I will just show you an example of how the credentials file will look like. Because my one has my own credentials and I don't want to delete that. No, thank you. Or another way you can do it is also, I think you can just do AWS configure. AWS configure. Yeah, if you do AWS configure, you can also, it'll like step you through, just insert all the stuff in there. Then it'll like create the stuff for you. Yeah, okay, if you want to create, because you can define multiple IAM access keys in the credentials file. Is there a picture I can use? Yeah, it looks something like this. So over here is rejected lah, but over here you can see, you can't really see, but there is a square bracket here. So if you want to create new accounts, okay, your default account, right, you just put square brackets here and then you put default inside, right? And then for the access key ID and then the secret access key, there won't be a session token. So these two you put the corresponding values lah. If you want to create new profiles, you can specify profiles, then afterwards when in AWS, right, you can just do AWS profile and then the profile name. So like test user, and then your other command. So this will run the AWS command in using this profile instead of your default profile. To do that, right, you just put, instead of putting default in here, you put their profile name lah. So for example, test user, right, then I'll put in square brackets here test user, and then the access key ID and the secret key. Okay, and then under configure, they'll also ask you for a region. You can specify a region or you can just leave it blank. If you leave it blank, then every time you run region specific actions, right, you need to specify which region you want to run it in lah. If not, you just use the default region. Yeah. I'll give you guys some time to set up your config file. In the meantime, I will redact the credentials and then I'll show you how the file should look like. So I have redacted all my credentials.
Oh man.
Oh man. So oh sorry, this one is it should be in small caps. I don't know if it matters actually. Maybe it doesn't matter. I'm not sure. Okay, so over here I have 3 profiles defined lah. The first one is my default profile. So if I don't specify in my command, I don't specify a profile, right, then it will default to this one. Then you put your access key and your secret access, your key ID and your secret over here. Then I have another one called I.YCEP test user, which I created, which I just created. Then you also put your stuff in here. I mean, yeah. Then if I want to access this one, I'll run something like AWS profile I.YCEP test user. Then for example, like STS get caller identity. Then it will return me the I.YCEP test user username lah. Yeah. Okay. Yes. But if you run, okay, so he's asking if you need to create the credentials file yourself. You can create it yourself, or you can also run AWS configure like this, and then they will ask you for the stuff, and you like put in it. Either one works. But in the end, what you are supposed to get is a credentials file that looks like this lah. Of course, with the non-redacted stuff. Okay, I'll give you some time to set up your thing so that you can follow along.
Where can I get that?
Compare more speed. Compare more speed. Copy all fucking.
Poly, my own Poly Wonderful Wonder lah.
Father, what you doing? Father, what you doing?
Poly mah.
Bro, this guy is
Shucks,
there.
bro.
Tidak abang, tidak abang.
Kena slam bro, instantly kena slam bro.
Where's the soundboard?
Times bro.
How did I get good at streaming?
Somebody was telling me.
How did you get good at streaming?
Funny bro.
Bro, mute.
Wait, I actually that though.
Mute the tape.
Yeah, I actually that.
This one 5117 eh. No, that's
I want to hire this.
higher.
Hey, wait, but I have FM and everything. What the? I actually FC the entire box.
What's your workshop?
Except for like the 3 star.
Workshop.
Too slow.
That's
Oh, that's my map that I gave you.
yeah, that's so nice bro.
Yeah, so you see, if I run get caller identity with this profile, right, then I'll get back the one for this user lah, for this profile. Then I'll get the user details for this profile.
Wonderful.
Then yeah. And if I don't specify, then it'll be my root user, which is one. Yeah.
I was trying to do like 300 kill.
Okay.
Heavily.
I'm gonna move on.
Only you can make
So right now I already configured my credentials lah. So and also created the bucket, right? So I should be able to list my buckets. So if I do AWS S3 LS, that will list all the buckets that I've created. And we can see over here, this is the bucket we just created. So let's try to upload something into it. What should I upload? Should I upload my credentials into it? I'll just create like a temp file. S3. Okay, let's say I just want to upload this file into it lah. AWS S3, copy the local file into. So this is the S3 URI. So how it works is you just put S3 : / and then your bucket name, followed by the file path that you want to put it at. So I also just want to put it at flag.txt. Then it will run. You upload the file. Yes. Okay. Then now if we ls inside, right, even S3 ls S3, or you can also don't specify a URI, then you just put the name. I.YCEP 26. You should be able to see the file that we just created. So let's say I want to view the contents of the file, right? I can do this at AWS S3 copy. So now by the URI 26 flag.txt to standard out. So if you remember, dash is an alias for standard out. Run this, then you will be able to see the contents of flag.txt. It's taking quite long. I don't know why it's so slow. It's usually faster than this. Maybe NUS Wi-Fi. Yeah, so you can see. Oh, okay. Flag.txt contains this lah. Then let's say I want to remove it. AWS S3 RM S3 I.YCEP 26 flag.txt. Then you run it, you can delete it. Yeah, so those are like some of the basic commands. You can continue to play around with like your IAM policy. If you define new users, you just see like, oh, what stuff you can configure and whatever lor. You can learn a lot just by experimenting with these stuff. Yeah, so this is just for the online people to follow. Okay, so now we've learned about S3 buckets and we've learned about IAM users. Okay, we're going to put some of these skills to the test. Okay, so there's this very nice hands-on thing that someone else created a long time ago. If you go to Floors of Cloud, you see this nice thing here lah. So basically for this hands-on challenge, right, the goal is to find the next level. So the next level will also look something like this. and then it will tell you, you have a description at the bottom, level 2 something something. So I'll just walk you through how to solve level 1 first, then you can try it for level 2 yourself. So this hands-on, right, they are using the static web hosting option for your S3 bucket. So this file itself, right, is a file on floors.cloud. Like the bucket name is floors.cloud, and then the file that we're viewing now here is index.html. So yeah, that's how they're hosting it. So the goal is to find the name of the next bucket, and I guess afterwards you'll be able to see all the names, but you need to find the specific file that has a description for the next level. So for level 1, I'll just walk through how to solve it first, then you can get a sensing of like how this whole thing works. So if you do, we already know the bucket name is floors.cloud, right? So AWS S3 ls floors.cloud, just to see what files we have in here. Then if you do ls, right, you can see we have permissions to view all the contents of the floors.cloud bucket lah. And there's this secret dd02c7c.html. We can just copy this and then we put it in here. So floors.cloud / the secret file, the secret file that leads you to the next level. Then you put it in, then you reach level 2. Then just click on it to go to level 2. Yeah, okay. So now level 2, the bucket name is this long string here. This is the bucket name for level 2. You can go ahead and solve level 2 and level 3. I'll give you 20 minutes. Level 2 is super easy. Level 3 is also quite easy, I think. 20 minutes for both. Okay lah, 25 minutes lah. 4:30. 2:30 you'll go through. Okay, never mind. I'll just do the walkthrough. Let's go.
This is your farming, is it? I don't know. Total track please 11,000.
Okay, so we left off at level 2, right? Level 2 is here. So now for level 2 is the same thing. The only difference is it only allows authenticated users to list the bucket. So for level 1, all users are able to list the bucket. Means you don't need to even have an account to list the bucket lah. To list to run the list bucket option. To run the list bucket action. For level 2, you need to have an account, but any account you do. So anyone can access this bucket. Anyone that has an account, I mean. So if you run this,
why I use the profile that then I list the bucket, right? They show me like level 6 and level 5.
they show you level 6, level 5, but if you go and try, right, if you try to cheese the challenge,
Cannot.
cannot.
Yeah, I was like, why is it show me like
Yeah.
level 5 and level 6?
So because okay, I'll get to that later.
Yeah, there's even what the end.
Yeah. The end is
highest
level,
yeah.
even you will get 20k.
Okay. Oh, I forgot to unfreeze this. There we go. Okay. So this is for level 2. You just run the same thing we ran for level 1, right? But on the level 2 bucket, you'll see we can find the secret HTML file here lah. Then we just go ahead and put /level 2. I mean /secret order. Then we reach level 3. Okay. Oh, by the way, for each of the levels, right, you can see basically what is the misconfiguration over here. You can see what caused this issue to happen lah. So if you are deploying your own things, you know to avoid these issues. If you are attacking things, then if you see, I mean you won't be able to see, but yeah, I mean I guess yeah, useful for people who are deploying their own stuff. Okay, now level 3. Let's try the same thing again. We list the stuff again. AWS S3 ls level 3.
Oh, you know, of course. Like you see here, okay, you just list off this score. Okay, your lowest is 204.
Then if you ls, right, you see, oh, there's no secret.html, not like level 1 and level 2, right? There's no secret.html, but there's this .git folder. that's all. Yeah, the .git folder. So maybe there's something inside the .git folder that is useful for us. So we don't want to look through manually. We can just copy the directory directly to our local directory. I'm going to create a new directory for this, loss level 3, and then sync level 3 to our local directory. So dot is local directory lah, and run sync. Oops, you need an S3 URI. So you need to specify S3// and yeah. Okay, we've got the contents of the bucket in our local directory, and you see the .git folder is here. Okay, let's explore what's in this Git repo. So if you run Git status, you can see, I mean, this is a valid repo lah. You can see he actually modified the index.html. Let's look at the commits. You can use lazy git to explore it, or like any git explorer, or you can just like run the commands, I guess. Yeah. Git log. Oh, so you see here there's a commit that says, oops, accidentally added something I shouldn't have. Right? So if you go to the previous commit, this is a commit we're on now. If you go to the previous commit and you run git checkout the commit hash, then now our directory will be in the first commit lah. And if you run ls again, right, you see that there's this file accesskeys.txt, and if you cat this on, you get certain credential, you get the access key and secret access key. This is not a flag yet, but from here we have managed to get a credential leak. So remember earlier I was talking about the misconfigurations that could happen, right? This is a credential leak. So with these credentials, most likely we have elevated permissions lah. We can do more things than what we could do with our own access key that didn't have any permissions, right? So you can go ahead and copy this. I already copied it to my credentials file. You can go ahead and copy it in. Then if you run AWS profile flaws level 3, get caller identity, then you can see this is another user now, and it's a valid user. Okay, now we are not really sure what we can do with this. There is a tool online that you can use to basically it will brute force all the possible actions that you can do in AWS lah. So it will just like enumerate, oh, can I list buckets, can I list instances, can I list lambda, can I, basically it will enumerate through a list of actions. For this, I mean, I won't be demonstrating that today, but it is a valid tool. I've used it before in other CTS, but we won't be needing it. It's quite easy. There are quite a few. One is called CloudFox, I think. CloudFox. Listen. So yeah, that it will help you answer the following common questions and many more. Then you just like brute force all the possible things you can do lah. There's another one, I forgot what it's called, but you can just can Google. I forgot what it's called.
I was laughing because my friend was slamming on the hatch like right now. He was complaining that he was online, you can't do this.
Oh. Okay. Anyway, after much trial and error, you might stumble across the fact that you have the list all buckets permission, or list all my buckets permission. So if you remember just now, right, if you don't specify a bucket for ls, if you have the permissions, it will list all the buckets that are owned by this user. And we can see here, this is the level 4. In fact, you can even see level 5 and level 6, right? But if you try to skip, if you try to go to level 5, it will tell you not to cheat.
straight go to the end one.
Yeah.
I'm not pronouncing
I don't know if the end tells you not actually.
for house of
It tells you the spelling, like essence.
traditional Maka,
Yeah, it does.
how do I say that? Something like that.
Yeah. So, okay, but if you go to level 4,
No, I don't know.
level 4, yeah, so that's the solution for level 3. So basically, recap is we found a Git repo. The Git repo has commit it has a previous commit that contains a credential leak, and then we use those credentials to pivot and to get elevated permissions to view all buckets. So if you didn't catch the walkthrough, you can refer to the slides. I'll send the slides tonight. Then you can refer to the walkthrough here lah. I think it's quite detailed.
What do you say? Oh,
Yeah.
ask Zui transfer to me.
Also, one thing to note, right, is that if you remember earlier we were talking about the list policy action. We don't have the list policy action. We are not able to do that. So if we have list policy action, right, then there's no issue. We don't need to enumerate all these already, right? We can just see what we are already allowed to do. But since we don't have this, right, we have no choice. We need to brute force this. So yeah. Okay. EC2. The EC2 is sorry. It is compute. Yeah.
Yeah, okay.
So EC2 is the traditional.
The current character more matter.
EC2 is the traditional infrastructure as a service, or like containers that you can spin up, virtual machines that you can spin up on the cloud,
It's legit.
right? You can configure different OSs to boot into. You can configure how much resources to allocate to it.
The blue color.
You can even create snapshots. So later we'll be looking at some challenges where you need to create. You need to
Character's good.
get a certain snapshot, and then you need to view the file system in that snapshot, right? But one difference is that on your computer, right, if when you spin up a virtual machine on your computer, it doesn't have a public facing IP. The public facing IP is your own computer lah. But for every instance, for every EC2 instance that you create, right, by default you can get a public IP for it. We'll look more about this. You'll look more at this like public IP, private IP thing later. But yeah, okay, snapshots first. So when you create a snapshot of an instance, right, the entire file system of that instance will be copied over into like this blob lah. And then you can take this snapshot, you can restore a certain instance back to that snapshot, or you can copy this snapshot out into another volume, and then you attach it to some other instance. Basically, you can mount the volume, then you can view the files inside the snapshot. Yeah, but okay, for rolling back the snapshots, right, you can only do it for I'm not sure if you can do it for other instances with the same configuration as the original instance, but I think if I'm not wrong, you can only do it for the original instance lah. I'm not sure about the other one, but obviously if the target instance is like running Windows and you want to roll back to a Linux snapshot, obviously you won't be able to lah. So yeah. Okay, so we mentioned about regions, right? So as we talked about earlier, EC2 is a regional service, is a regional resource. So if you create, in fact it's also affected by AZ. So if I create an instance in a certain region and a certain AZ, right, that instance will not be it will not exist in the other region lah. It's only created in that region, right? And earlier I also mentioned that for snapshots and volumes, you can only attach it to other instances in the same AZ, so in the same region and the same AZ as the target instance. So you cannot copy a volume. You cannot. You can create a snapshot in a certain region. You cannot copy that snapshot to another region. I don't think you can. And if you want to create a volume from that snapshot, right, you can put it in one of the AZs within that region, but you cannot copy it out of that region lor. And also, once you create a volume in a certain AZ, right, you cannot attach that volume to an EC2 instance that is running in another AZ.
Wait, the volume is referring to EBS.
Yeah, EBS. So this snapshot, I'm not sure about snapshots, but volumes are supported by another kind of service called EBS. But for our purposes, right, we won't be looking at EBS lah. You'll just be creating volumes from EC2 instances. But in the back end, it's supported by EBS. So you are interfacing with EBS in the end. Okay. So when you create when you create a group of Docker containers, right? Let's say when you use Docker Compose, then they will spin up a private network for you, right? This private network also exists in EC2. So in EC2, you can network a group of instances together such that they can communicate via their internal IPs in that network instead of using their public IPs. Right, so you can see here in this diagram, this guy here and this guy here, they are in they are all in the same region and they are all in a VPC, but they are in different AZs, right? And all of them are in an internal. They are not public facing. Only this guy. So this is another instance, right? This instance is public facing, and yes, the gateway. And I guess this is I don't know if it's in. It doesn't really matter if it's in AZB, but I guess it's in AZB lah, according to this diagram, right? So instances in different AZs can be in the same network, but instances in different regions cannot be in the same network. So only this networking thing is only it is across AZs but not across regions, right? Then you can see this load balancer or this gateway, right? Basically, he can direct requests to different AZs depending on their load lah. So we call this a load balancer. So let's say this AZ goes down, AZA goes down. At least you have B and C that can still support the gateway or the load balancer. Yeah. And if you want, for some reason, if let's say the guy in AZA is a database and then the guy in AZB is a web server, right? They can communicate with each other via the internal IP so that you don't have to expose your database to the public internet. Yeah. So this is called VPC, virtual private cloud. The reason why you want to do this for most of the services, right, is that AWS actually charges you per hour per public IP, and per hour this is 0.5 cents per hour. That is what, 12 cents a day. Okay, I mean it adds up lah. So if you want to prevent additional charges, right, you need to reduce the number of public IPs you have. I guess it's cause I mean AWS also has a limited amount of public IPs it can assign, right? So it doesn't want you to waste these IPs.
You can always buy more.
I guess, but it will cost them. So they transfer the cost to you. Basic economics. So as much as possible, not only for security reasons but also for budget resource reasons, right, you should try to configure your container without a public facing IP lah. But of course, I mean, if you're only deploying one instance, then that instance has to have a public facing IP. If not, like, you can't access it at all. Yeah. But if you have like multiple instances, then you can configure it such that you only need one public facing, and then you can use that as the gateway to communicate to many other internal instances. Yes, and also by default AWS will create a VPC for you in each region and each account. So each account has n number of VPCs created, where each VPC is where n is the number of regions that the account is subscribed to. Yeah, so we really talk about how it's restricted by region. you can also create your own VPCs with your own firewall or your own networking rules, if you so require lah. Yeah. Okay, one last thing about EC2 instances, you can also attach an IAM role to an EC2 instance. So basically, sometimes you want this EC2 instance to be able to access certain resources. So let's say you want this instance to be able to list contents of a bucket, right? Then you need to assign a role to it, or you could do it in other ways, but one way to allow access to that S3 bucket, right, is to attach a certain role to it. And then when some program is running in the EC2 instance, it can request for that role, and then it will be granted the role, and then using that IAM role, it can access the S3 bucket. But sometimes we misconfigure our permissions. We allow the user to let's say create an instance, right, and or maybe even just attach a role to a certain instance, right, not even create. But this we give it two broad permissions such that it can attach another role, a role that has higher privileges than its own, to the EC2 instance. Then if it's able to access the EC2 instance, right, then it's GG lah. You can privilege escalate via this add role to instance profile. So actually, okay, we didn't deploy this hands-on, but if you have your own time, this repo over here, right, CloudGoat, it has a lot of different scenarios, different like scenarios that you can go and deploy, and it's written using Terraform. So you can go and Google how to use Terraform to deploy stuff lah. They'll deploy AWS instances. In this scenario, what happens is that the user that you start off with, right, he's able to attach another role to, he's able to create an instance first, and then he can attach a role to the instance, and then he can SSH into that instance and request for that role. And now with that new elevated role, right, he can do other stuff and then get the flag. You can see the attack path here. So start with this guy, then you find a target role, and after that you attach it to your instance, and you create an instance, and then you do something, do something bad. So if you want more cloud practice, right, you can go to CloudGoat. Just go to here, under this directory, then under AWS, there are a lot of different scenarios where you can play around. You just need to give Terraform your AWS credentials, and then you deploy the stuff, right? Then you can try out the challenges lah on your own. Yeah. Okay. Let's go back. Okay. So this is one way where you can exploit the IAM attach, or you can exploit EC2 instances using the IAM attach permission. What's it going on? Come back.
What could you have possibly done? A screen after like you. Why is the screen also closed?
I don't know.
The TV off?
It should be turning back on.
Press the off button.
I don't know.
Is that a camera? Is that a camera? What is a projector? Is that a security camera? Is it not the projector? It's not projector.
What is that?
What's the projector?
Wait, sorry for the technical difficulties. I don't know. It just decided to turn off on its
The
own.
one the press you take off.
Yeah.
Because I only do web.
Yeah. Only web. Yo, what's wrong with this?
No, this is some hardware-based technical difficulty, not simple.
Hardware difficulties.
Why don't you just screen mirror? I don't think it's simple.
A okay, we are back. Okay. Alright. Sorry for the strange stuff. Okay. Okay, just now for the IAM user, right? How it's actually implemented in EC2 is via this IMDS service. IMDS. Instance metadata service. And actually there's a lot of other data that you can find on this IMDS. The IAM user that we attach to it is only one of the many metadata that we can retrieve lah. So internally in an EC2 instance, right, there is this internal endpoint at 169.254.169.254. Is defined for all I mean by default all EC2 instances either use V1 or V2 lah. But by default it's V2. You can optionally change it back to V1 for CTF challenges. So V1 was the original one. V1 basically the moment you have SSRF on your instance, right, you can basically query the entire endpoint already lah. For okay, I'll say more about the difference between V1 and V2 later. But for V2, it's supposedly more secure because you need to use a session token to access IMDS V2. And in order to get this session token, right, you need to send a put request. And not many SSR vectors allow you to send put requests. Most of the time is get request only, or at the very most post maybe. Put is very rare for SSRF, right? And in addition to that, a lot of proxies, right, when you forward request, it will have this X forwarded for HTTP header. It will check the request to see if it has this header. If you're not familiar with HTTP headers, I don't think it was covered in day one. But basically, for a lot of proxies, right, when you forward a request, it will say X forwarded for, and then the source, the guy that sent the request. So let's say I'm let's say my hostname is Samuzora, right? Samuzora, then I send a request, then you say X forwarded for Samuzora. Of course it will be an IP here and not a hostname, but that's how it works lah. So if IMDS sees such a request, it will think that likely is a SSRF attempt, then it will block the request. So these additional layers of security, I guess you could call it security, will help to mitigate like SSRF attacks, so that you won't be able to compromise the entire EC2 instance if you have SSRF. Okay, we'll take a look at IMDS V1. Over here, this is an example of what you would get from IMDS V1. And by the way, the endpoint is /later/metadata. So if you just visit this IP, right, you will get 404 lah. You need to get /later/metadata. Then you'll see there's a list of paths here that you list out. Then after that, you can go and explore what is AMI ID. This is the machine image ID, I think. The host name, etc. Then of note is this one lah, IAM. So if the instance has an IAM attached to it, right, if you go to here, this is how you get your short-lived IAM tokens from this directory from this path in the IMDS endpoint. Yeah. There's a lot of other info that you can go and like take a look at later. And to take a look at it, we'll be deploying our own EC2 as well.
You don't need to pay for that.
It's not much, bro. It's like cheap.
Just use Oracle, but Oracle has no more VMs now. Sad.
Okay, I'll just walk through how to deploy an instance. Okay, if you go to, where is my AWS? Here. Okay, so if you go back to your AWS dashboard, right, the web console, then you click on the squares again, compute, then EC2, then there's a nice button here that says launch instance. So if you click on it, you present. Okay, there's a lot of configuration that you can do in this page. Okay, but you don't need to do all of it lah. So let's just say I don't know, I.YCEP something test EC2. Okay, then you can configure the OS here. So there's a lot of other OSs. You can put Ubuntu or Amazon Linux, up to you lah. Yeah, I'll just put Ubuntu.
Specs.
The specs you can configure later, not here.
Pay more money, guys.
Yeah. Okay.
Just use
Okay, here. So then over here you can, there are certain combinations of specs that are already defined for you. So the default I guess is T3 micro. You can get bigger ones if you need T2X large. But you don't need lah. Just leave it as T3 micro. The biggest one, whoa, 24X large, 16X large, 64 virtual CPUs.
Be careful though, they will charge you.
how to rack out a $50 million AWS with 2 seconds.
Yeah, so please don't deploy these extra large instances unless
Credit card can save you.
no, just don't, please.
Got enough money.
Just select the free tier.
Yeah, bro. The default one is the free tier. Don't need to change. Okay.
One is like better though.
Then next one, right? In order to log in to access your instance, well, you can also access via the web console, but it's a lot nicer to do it via SSH lah. So you can create a key pair here. If you don't have one here already, I already created one. You can click on create new key pair. Okay, one more thing to know, right? I forgot to mention. Make sure that the region is in the region that you want, because the region configuration is not in this page, it's over here. So you need to make sure that you are in the region, the correct region lah. Let's say I want it in Singapore instead of US West, right? You just change to Singapore. Then yeah, then you now you'll be deploying in the Singapore region. Okay, then okay, if you haven't created a key pair, you can just click on create, just name it something, then it will give you a key pair to download lah. I'll just create a new one to show you guys how it works. So I.YCEP walkthrough. Okay, create key pair. Then after that, it will just give you the public key. Then you can SSH in. Storage, you can configure. I don't know what all these are. S3 files. Whatever. Yeah. Okay, one more thing. Just now we mentioned about AZ, right? We didn't see anything about AZ here. AZ is under here. So if you click on edit, there's a pop-up here that says you can configure your AZ from here. Then this will be important for one of the challenges later. So you need to make sure that you put it in the right AZ. So if you put the wrong AZ, then you can't do certain things. Let's put it in AZ1. Okay. Yes. Over here under advanced details, right? If you open this pop-up, if you open this drop down, sorry. Open this drop down, you'll see that you can specify the IMDS version. Oh, you can even disable it if you don't want it. But over here, metadata version, by default is using v2 only. So if you this is the recommended default lah. You don't need to enable V1, but if your system has some legacy thing that only supports V1, or if you are making a CTF challenge, then you can change it to V1. I'll change to V1 so that we can explore the IMDS together. Yeah, okay. Think that's about it. Let's scroll through to make sure everything is correct. Then launch instance. Okay. Then after you launch instance, right, it will show you here the instance ID. Then you can click on it. Then you can see some details about the instance lah, like the IP, which IP it got. Then using the SSH key that you downloaded just now, right? Can copy it over to some other directory. Let's say EC2 walkthrough. And then make sure that the permissions are set correctly. So for SSH keys, right, just run changeport 700 on your key. After that, you can try the SSH in SSH. If you created an Amazon Linux instance, right, then your login user would be either EC2 user. So you do this -I.YCEP. If you use the Ubuntu one, then your login user is Ubuntu. I use Ubuntu, so I'll be logging with Ubuntu. Then you can see we can SSH in lah, and it's a new instance for us to play around with. And let's explore the IMDS 169.254.169.254/latest/metadata. Then you can see you can view certain information about your instance lah. Let's say the ID, this Amazon machine image ID, instance ID. Yeah, so all this stuff is meant for services that are running on your instance to query. But if an attacker manages to query these, right, then he can potentially access some info that he's not supposed to be able to access lah. Okay, then now let's also take a look at some AWS, some EC2 commands that you can run. So yeah, this is for the is there a I didn't put the slides in here. Okay, but let's say you're on your root user, right, then you have permissions to list instances. You can just try out lah. AWS EC2 list instances, and remember you need to if I don't specify a region, then they'll tell me here, describe instances, sorry. Describe instances. Then you must specify a region lah. So for me, my region was AP Southeast 1. Then describe instances. Then you can see here, right now I have 2 instances defined in AP Southeast. It's like in JSON form, you can see some info like the IP, other stuff like, yeah. Okay, I mean you can also go to the web console and look at it, but if you're doing a CTF challenge, right, then your IM user most likely won't have access to web console. That's why you need to learn the commands itself, right? So if you go to instances here, then you can see, I really do have 2 instances running lah, and the instance IDs match up. Now I have another instance that is running in US West 2, I think. US West 1. I kind of forgot which region I put it in. Yeah, I low-key forgot which region I put it in. But if you have another instance somewhere else, right, this instance will not show up in let's say if I list instances for describe instances in AP Southeast, right, it won't show up in the output. So you need, when you specify the region for describe instances, it will only show you the instances in that region. So when you are doing like some CTF challenge, let's say you need to find, you need to like enumerate what resources you have access to, right? You need to make sure that you check all the regions lah, just to be sure that you didn't miss any resources. Yeah, okay. We will go back to this later in one of the challenges. Okay, if we deploy our EC2, before we do the hands-on, right, is there any other stuff that, okay lah, I think there will be some other commands that you need to go and discover on your own. Just use Google. Google is quite easy to Google and stuff. You can also use the help command. So if like you do I.YCEP help, then you can see the list of actions that you're allowed to do. All these are. You have to be a bit patient. You need to go and read the thing. You can Google. Up to you. Okay. So now, you'll be going through levels 4 to 6. I'll give you some time to try, but I'll give you more time now. This one is okay. For level 4, I'll give you level 4. I'll give you I'll give you 30 minutes for level 4. Okay. For level 4, just do read the description. So the description tells you that there is a snapshot made of the EC2 somewhere, right? Then this will be helpful lah. You need to use the snapshot to do something. Yeah. Okay. 30 minutes. 350. 350 we'll go through this. Let's put on the music. Okay, I'm going to start the walkthrough. Oh man, I like the song. Never mind, we'll play it later. Okay, let me start the walkthrough. So, for this one, right, we have EC2 instance running here lah, and we try to visit it, right. You ask for username and password, right? So, the answer is not to brute force the username and password. So, it also tells us that there's a snapshot. So likely, if we can access this snapshot, then we can probably get the volume from the snapshot and then view the file system, right? View the EC2's file system. So if you run I.YCEP help, right, there's a command describe snapshots. Describe snapshots will list all the snapshots defined in that region. So I.YCEP region. Okay, let's say we go with AP Southeast one first. Okay. EC2 describe. Oh, sorry. Sorry, the screen wasn't sharing. Yeah, it was frozen. Okay, my bad. Okay, I'll just go through that again. So, in this level, right, you have an EC2 instance defined here. There's a password here, and we need to use the snapshot to. We need to explore. We need to access the snapshot basically, and then view the file system and then get the password from there. Okay, so if you run I.YCEP help, then you search for snapshots, right? Snapshots. Then you see there is a command called describe snapshots. So I.YCEP describe snapshots help describes the specified EBS snapshots available to you, or all the EBS snapshots available to you. So this is a regional thing. So if you run I.YCEP describe snapshots just like this, right, it asks you to specify a region lah. You must specify a region. So let's say I go with AP Southeast one. That's Singapore. EC2. It's gonna take a while, but basically the outcome is that there are no snapshots in or rather, sorry, for this profile. So,
Even you brute force all the regions.
yes, so we'll be brute forcing all the regions. Flaws level 3, describe snapshots. I believe there's another flag that we need to set.
Can you just check where the guy is from? We'll use the region closest to his house.
Well, that doesn't work all the time. There is another flag we can. Yes. So, if you do describe snapshots, right? If you read the description here, it will actually show. It will list all the snapshots available to you, which is a lot. There are a lot of publicly available snapshots, but we only want the one created by the test user, right? The user that we have now, we have access to now. So we can specify owner IDs, and if you search the owner ID syntax, right? Owner IDs. You just put the ID as a string lah. And how to get our ID is using, we already did it just now, right? STS flaws level 3 STS get caller identity. Then you can see the user ID is this lah. So now back to our EC2 describe snapshots. Profile flaws level 3 region AP Southeast 1 EC2 describe snapshots owner IDs. Wait, is it this one? Ah yeah, okay, sorry. Is this account ID, not user ID, my bad. So if you list in, so right now we are listing in AP Southeast 1, right? You can see that there are no snapshots defined. Because obviously the guy who created this flaws of cloud is not from Singapore lah. He put it somewhere else. So I guess you can go and try the regions one by one, or if you want to speed it up, you can actually write a Python script for it. So I'll just write the script right now. Yeah, am I lazy? So I have the source script here lah. Oops. Okay, so what this script does, right, is basically list all the regions. So if you run this command, right, you will list all the regions that are available to the EC2 service. So profile flaws level 3 region AP Southeast 1 EC2 describe regions. Then you can see it will output a JSON, a very long JSON document, and then you can see there's AP South 1, EU North 1. So we can just pass this JSON to get the list of all regions defined, all regions that are available to the EC2 service. Okay. Then for each region, we go and check if there are any snapshots in here. Oh, you can even do owner ID self. I forgot about that. So if you put owner ID self, right, then you don't need to go and find your user's owner ID lah. You just use self. Then you just list out all the snapshots that are created by you. In this case, you is the flaws level 3 user. Okay. Okay. So if you run this, it will take a while. Then you iterate through all the regions until it finds one where there are snapshots defined.
How do you get ARS?
Give it one more second. Okay, there you go. So we see that in the US West 2 region, US West 2, there is a snapshot defined here. It's the only region where there was a snapshot. So let's take a look at it. This is the snapshot ID, and this is the volume attached to the snapshot, or rather, the snapshot itself contains. This is the primary volume that is attached to the snapshot. Okay, let's take this snapshot ID. Then we go and search it up in the web console. So I know some of you use the CLI. I use the web console to do this lah. You can call me a normie, but if you go to snapshots,
No one's discriminating.
then change to US West 2. Make sure your region is correct. Then snapshot scope set to public, and then say snapshot ID. Snapshot ID is equal to the ID that you found in the CLI. Then you see, okay, I managed to find the snapshot ID here. If you click on it, then you go to actions, right? There's a option for you to create volume from snapshot. So go ahead and create it. Now some of you might have been creating the volume from your CLI, and you might have noticed that you don't have permissions to create volumes because you may have forgotten to change the user. You may be using the flaws level 3 user lah, right? But that user doesn't have permissions to create volume, so you need to use your own user, your own account to create a volume. So click on create a volume. Scroll through. Take note of the availability zone. So it's in AZ2 or US West 2A lah. Just take note of that. Then create volume. Okay. So now we want to view the contents of this volume, right? We want to mount it. You want to attach and mount it to an instance. So in the same region, now we're in US West 2. Let's go to instances. Let's create an instance. Flaws level 4. Okay, change to Ubuntu. Same thing, just all the stuff that you did earlier. Flaws level 4.
Yep.
US West 2. What is damn laggy, bro?
Open SSH. Oh, you need VPN to connect to this thing?
Okay.
You need a VPN. Don't need, right? PEM.
What do you mean do?
I don't know. His application.
Ask the big T one.
Why does it have a PEM?
You wanna look at our cryptography project? Please explain.
Yeah, please explain.
Okay, anyway. Okay. Now we need to take note of the availability zone, right? So under network settings, click on edit, then set it to AZ2 because we created the volume in AZ2. So your instance also has to be in the same AZ. Then besides that, nothing else to configure. Let's launch the instance.
You mean the key?
Okay. In the meantime, I'm gonna copy the key over.
You know what? Why is the PM in?
Then change the permissions.
Oh, I think the key panel.
And we SSH in. So our IP, you get it from here. Copy address, and then we SSH in. SSH Ubuntu at IP-I your private key. Okay, so now we're in the instance, right? Now we need to attach the we created the volume just now. We haven't attached it to the instance yet. So if we go back to volumes. Oh, I didn't take note which volume. I didn't take note of the volume ID. Let's see. Okay, this one. So we have two volumes here, right? Because the first instance, I mean the instance that we created, right? It also has its own volume. So you can see here, there's one in use, one available. The available one is the one that we created from the snapshot. This one is the one that was created by default when you spawn an instance. So now we want to mount this volume to the instance. So you attach it here. If you didn't catch it, you select it, right? Then you click on actions, attach volume. Then specify your instance, and then it'll ask you for a device name. So you can just put this one lah, SDB. Doesn't matter what you put. Okay, and then attach volume. You see it's in AZ2. Oh, it's already in use. I guess
everything is just
SDC works also. Why is it already in use? SDC.
Whoever.
Attach. Okay, I let me SSH. I mean, let me exit the SSH first. Oh. It's so weird, yeah. Try M. Okay, this is not supposed to happen. I don't know why. I don't know why it's saying all the devices are used. Maybe you use one of these. Try this one. XVDBB. Okay. SVDBB. Okay, then we SSH right in. Then take note of the path that it was attached to. If you ls-dev, right, you'll see that it should create where is it? Okay. Wait, it's not create. Oh. That's pretty strange. Let me try to see why it's not.
I give up on the CLI already. Just use the console.
Yeah, just use the console.
Just use the console.
Yeah, I detach the volume first. I don't know. Something wrong with the.
I cannot find the lag shot also. It's like glitching. It's like very lag.
Yeah.
Yeah, it's like glitching or a bit lag.
You must change to actually I'm not very sure why. Detach. Oh, it's in the available still. Okay. What? I can't attach it anymore. Okay, let's create a new volume from the snapshot again. I don't know. This has never happened to me before. This is a snapshot ID. Oh, it's here, yeah. Create volume in AZ2. Create volume. Back to instances. Oh, back to this one. Oh no, now you have two. I forgot which one is the. Yeah, I guess this is the one. SDB. Please work. Wow. Okay, I think it may be the instance, something wrong with the instance that I don't know what is the issue. This thing has never happened before. I'm going to delete this instance and try again. Actions. Instance state. Terminate instance. Maybe I use the Amazon Linux one. Last time I used the Amazon Linux one for this challenge lah. Launch instance. Okay, then select the key pair. Configure the AZ. Configure the AZ. Launch instance. Okay. Okay, then let's remember the ID, 0ED. Then you go to here, maybe refresh. Zero ED, this is the one. Then SDB. Attach volume. Okay, great. I don't know what the issue was with the Ubuntu one. I guess we can use this one. Do you use the so if you encounter some issues with trying to attach the volume, right? They say it's in use already. I guess you can use the Amazon Linux one. I don't know, maybe the Ubuntu one got some incompatible stuff. Then we copy the IP and SSH in. For the Amazon Linux user, right, it's EC2-user, not Ubuntu. Then -I. Yeah, SSH key. Okay. Now we are in. Then if you ls-dev /dev, you'll see that there's a device define where's the device? Wait, SDB, right? SDB. Yeah. Okay, there's. Am I blind? I can't see the SDB. There we go. So SDB is the. If you're familiar with like mounting this in Linux, right? Usually when you mount a disk, the entire disk is mounted on this device, and then each disk has a partition. So we have one partition in this device, and it's SDB1 lah. So we want to mount the partition, not the disk. Okay. So to mount it, we just do sudo. Okay, we create a mount for it first. Floors level 4. Then we mount it. Sudo mount /dev/sdb1 to floors level 4. Okay, so now if we cd inside, you see that this is the file system of the EC2 instance that we were trying to attack. So this EC2 instance, this is the file system, or rather it's a snapshot of the file system lah. So our goal is to find the username and password, right? If we see to home, you see that there's this setup nginx.sh here lah. You can also, I mean, okay, when the first time when I did it, right, I just went straight to /var/www/html. If you go inside, in this /var/www/html. If you go directly here, right, then you can index.html, you can already see, you can find level 5 lah. But this is like a cheese lah. I mean, you're supposed to find the username and password. So to find username and password is at the home directory. It's in home Ubuntu. Oh, Ubuntu. Then there's this setup nginx.sh. Then you can see the username. The username is floors and the password is this long string. So if you just put it in floors password, then we can access level 5. Okay, that's level 4. Level 5, now we will be dealing with the IMDS that we learned earlier. This one is basically just a SSR vector lah. You can see if you visit floors.cloud, then it will just proxy floors.cloud for you. Then you can visit like other websites. Yeah, so this one should be quite straightforward. I think because you guys have already done SSRF, you guys kind of know the IMDS format. So I'll give you 15 minutes for this one. You can try to, basically the idea is to get the IAM user attached to this EC2 instance lah. This proxy EC2 instance. Get the IAM user, then you should be able to list the contents of the level 6 directory. The level 6 bucket. Let's go.
I don't think so.
Okay, let's start the walkthrough for level 5. So level 5 is just, I mean, we already went through like all the theory just now lah. So now it's just putting it into action. We go and visit the proxy. Then we change the URL that we're visiting to the internal IMDS endpoint, right? /later/metadata. Then you visit it, you will be able to see the IMDS of the proxy EC2 instance lah. Then you can see here there's this IAM directory, right? IAM. So we go into it. /IAM /security credentials /flaws. Then you see here it will generate the access key, the SS key ID and the secret access key. Then you can just go ahead and copy this and put it inside your configure file. Okay. So this one is a short-lived IAM credential, right? So you cannot put it in from AWS configure. So you need to edit the credential file directly. Okay. For ease of viewing, I'm going to paste it in here instead.
Oh, you give away.
Okay.
Give away. What's the server? The server piece server. The owner sold it to this for what the fuck is this?
Okay. So now our user is flaws level 5. Then AWS access key ID equals to this one. AWS secret access key goes to this one, and the session token. So you just copy this. Copy this one. Oh wait, I've been using the wrong one. Oh no, that's right. AWS session. AWS session token, I think. Okay. Okay. Now we managed to create our profile for the temporary user lah. So now we try to list the bucket from just now. If you remember from the flaws level 3 user, right, we have this level 6 bucket that we saw. I hope I still have the let me list the buckets again. Move. Okay, so let's see if we are able to list the level 6 bucket. So I move it back. 10. Move back up. Okay. Move credentials. Okay, then using the flaws level 5 user, then we list the contents of this bucket. S3 ls level 6. Okay, then you can see there's a secret directory here. We can go ahead and list what is in this directory. Right. Then you can see there's index.html lah. So we go ahead and visit this secret directory, and you should be able to see the link for level 6. Okay, so now for this final one, for the final one, because there's a new concept that we haven't learned, which we will be going through later, but I just want to do a walkthrough of it first, because this one is a bit guessy in the sense that you need to like enumerate through a lot of different things lah. So I'll just do a walkthrough, try to follow along. Okay, so sorry. So now we're given this user, this level 6 user. Can go ahead and create a profile for it. So many credential files now. RM credentials. Move backup cracks. Okay, this is the flaws level 6 user. And we are given an access key Oh, actually, we use the ADS configure. ADS configure profile floors level 6.
Another one. So you want your P6?
Nope. This one. This one. Okay. Now check if our profile works. Yeah. Okay, so this is our level 6 user. So in the challenge description, right, it tells us that there is this security audit policy attached to our user, right? So we need to find out what this policy allows us to do. So let's list the policies attached to the user first. You can do that with IAM describe policies only attached. So if you run describe policies help, right? Okay. IAM list policies. Yeah, list policies. So if you run list policies help, right, you can see that there's this flag you can specify only attached or no only attached. So no only attached means that you only list the policies that are attached to your user, right? If you don't specify this, then you're going to list all the policies that your user is able to view. So you don't want that, you want to just see what are attached to your user. What is attached to your user? Only attached. Then you see there's a long list of long list of policies that come out, right? So over here it says it has the security audit policy. So let's search for the name, and it's over here lah. You search for the name, you'll see that there's this policy called my security audit. And anyone can tell me, is this a managed or inline policy? Is this a managed or inline policy? So inline policy is, does inline policy have a version? You can see this one got version, right? Do inline policies have versions? Don't have, right? Because your inline policy is defined on the fly. You don't specify a version for something that you just define on the fly. But for managed policies, because it has a name attached to it, the contents of the policy can change as the version changes. So this my security audit policy, you want to view the JSON the JSON document for this policy. And we see here default version ID is 1. We can still we can confirm this lah. We can get policy, and then we see what is the active version for this policy. So AWS this policy, I think get policy, then they'll ask for the policy, they'll ask for policy ARN. So I think if we specify the name, it should be enough. Oh no, you have to specify the full ARN. So you go back to here, you copy the whole ARN, and then put it in. So if you remember this morning, I said get policy only gets the only shows you the versions for this policy. It doesn't show you the document itself, right? So you see here is v1 lah. So now we get policy version. Get policy version. And policy version will expect version ID as well. So you need to specify version ID v1. Okay. So now this policy actually has a lot of actions that is defined for us. We can do so many actions in here, right? And this is the reason why I didn't want you guys to do it on your own, because honestly it's not very educational if we just throw you a very guessy challenge and ask you to do it lah. So to cut things short, right, basically if you enumerate through all of these things, right, you eventually reach this one, this lambda list asterisk. So this allows you to list all the defined lambdas. In fact, list all lambdas in it allows you to execute list asterisk, which is like list anything, right, for the lambdas. So let's look at what list actions we have in lambda. AWS lambda help. Search for list, right? There's list aliases, list functions, list state, all these lists, so we can execute any of these actions lah. I mean, let's go with list functions. I think that's the most logical. Profile floors level 6 lambda list functions. And for list functions, okay, let's just run it. Okay, need a region. We go with the same region as just now, US West 2. If we wanted to, we can brute force this, but we don't. I mean, we can just assume it's the same one. Okay, so there's a function defined here, the level 6 function, and yeah, okay, there's the level 6 function defined here lah. Let's see if we can invoke the function. Okay, AWS lambda invoke, then invoke will ask you for a function name. Function name is level 6. Okay, out file is standard out lah. Okay, our user isn't authorized to invoke function, right? So how? We cannot invoke the function, but we know that now our goal is, because we know that this function, this lambda exists, right? And our goal is to invoke this lambda. So let's look at the lambda again. If you describe the lambda, right? Let's see if you have permissions to describe lambda. Hey, we have permissions to get policy in lambda, right? So if we take a look at get policy, look at what it does. It returns the resource-based policy for a certain lambda, for a given lambda, right? So now we can view the policy for our level 6 lambda as well. So function name level 6. You specify the region.
Oh my god, and then I scroll down there and I see.
Okay, there's a policy defined here. This is an inline policy. So just to prettify it, right, you can print it out in Python. Print. Oh, okay, there's no new lines. Never mind. Yeah. Let me prettify it. Do I have pprint here? No. Oh. Okay, never mind. It's not very pretty. Anyway, in this JSON document, right, we have one statement. You can see this is a statement, and the statement allows us to execute invoke function, right, on the condition that the source ARN is this thing, this long ass thing here, right? What is this? This one is execute API, or the API gateway service, and is in the US West 2 region with this is our user ID. This is the name of the API gateway, and this is the path. This is the get is the, okay, this asterisk here is we will look at it later. Okay, get is the HTTP method that we are supposed to use to call the API gateway, and level 6 is the path that we need to call the gateway at. Okay, so that was a lot of things that you need to take note of, right? But basically all we need to do is we need to find a specific API gateway that we send a GET request to at this slash level 6 path. Then if you're able to do that, right, probably in the back end we don't know how the API gateway is defined lah, but since it is given the permission to execute invoke function on this lambda, right, we can assume that this API gateway is configured to invoke function, invoke on our level 6 lambda when we successfully make a GET request to it lah. yeah, effect allow, and the resource that is attached to is the level 6 function. Okay, so now how do we get this the URL for this API gateway? So if you search AWS API gateway URL format, the URL format is in this format. Okay, so API ID dot SQL API dot region dot Amazon AWS.com slash stage, and then afterwards any further directory for ours will be level 6. So here we have 3 variables that we need to get: API ID, region, and stage. So back to here. Now we need to find this API gateway in using our level 6 user. Floors level 6 API gateway help. So let's see if there's a way to list describe get. Okay, get REST APIs or get REST API, either one. Since we know the ID already, right? We know the ID from here. We can see. Okay, I guess I skipped a step lah, but this is the ID of the REST API. Okay, so we can just use get REST API directly to get more info about this REST API. Get REST API, and it will request for a REST API ID. So REST API ID. We need a region again. Region US West 2. Okay, so these are the details about this API gateway, right? But it still doesn't tell us where the stage is. So if we go back to here, scroll down, there's another one. There's another action we can do, which is get stage. So or get stages lah. So we want to list all the defined stages in this API gateway, in this REST API. So get stages. And then we see there's only one stage that's defined, which is the prod stage. Okay, so now we have all 3 that we need. We have API ID, we have region, and we have stage. So let's go and execute this in our terminal. So stage is prod, and then remember that we want to go to the level 6 endpoint. Okay. API ID, as we found earlier, is this one. Oh. And region is US West 2. Maybe you can't do it in Chrome. Let's try it in our browser.
harder than the OSCP. But what's the difference? There's no certificate. There's no difference. I don't know what's the entirely hands-on.
Hey, I think the challenge broke. Wait, what the?
No, check what's the word OSCP.
I see.
Wait,
If you just go on IC,
did the challenge break?
all fantastic.
ESS2. This isn't supposed to happen, but okay, I don't know what happened to their API gateway, but I tried it a few days ago and it was working well. So if you curl it right, by right, oh maybe it's small level 6.
Right.
Oh okay, yeah, sorry. It's not capital L, it's small L. Where did we make this mistake? Level 6. Yeah, my bad. It's small level L, not big level L. Okay, scare me. I thought the challenge broke. Okay, so that's the end. We got to the end. If you open it in your browser, we got to the end of floors.cloud. Yippee! There's also another one, floss2.cloud, which you guys can go and try on your own. But actually, like, I was trying it on my own. Actually, I wanted it to be part of this workshop also, but some of the stuff that they put there, right, is like not working anymore, sadly. So you can try some of them on your own. Just read, maybe just read the write-up lah. Yeah. Okay, so level 6 was more similar to the kind of challenges that you're going to see in the CTF. There will be a bit of like enumeration involved. It's not so straightforward like the level 3 one. You just clone the repo and then like get the repo. After you go and look for the keys, it's going to be more services tangled together lah. Many different things you can do, and the path that you want to take is not so straightforward. Yeah. If I were to let you guys try, in fact, when I was trying it myself also, it took me like quite long to do. I think like maybe 1 hour. So if you guys were trying your own, it will take too long lah. So that's why I wanted to just go through the challenge directly. Okay, so this is the last part of the lesson. We just have a small theory session about lambdas, which we saw just now in level 6, right? There was this lambda that we wanted to call. So lambdas is a very new concept in, okay, not very new, but it is a relatively new concept in cloud computing. So the idea is that a lot of actions that we want to run, right, actually we don't need a server that is running in the background all the time. We can just have this thing called a serverless function, so that you can invoke a lambda directly without having to maintain a server, pay for the server uptime and everything, right? Instead of doing all that, you just have a certain API that you can call for you to execute actions on demand, right? And we notice that a lot of our actions are somewhat like this. So let's say you want to register a user for an account, right? Register user, you don't need a server running in the background 24/7 waiting for people to register for your service or whatever, right? So you can just use lambdas to do this. So lambdas is very good for these like one-time actions that don't take very long. Yeah. And also the good thing about lambdas is that you pay per execution, right? Per execution and also per,
I thought it's time.
yes, per execution and per time per execution, right? So
The seconds or something.
yeah, CPU
It's like minute or like
something like that, yeah.
I forgot already the pricing.
So with lambdas, right, you can automatically vertically scale your, would this be vertically scaling? You can scale your service lah. You can scale your service like almost infinitely, depending on how much money you have, of course. But you can scale your service and you don't need to like reconfigure your server or increase the RAM, increase CPU. You just let people, as more people come in, your service will scale. So it's a very good way to save some money lah, if you define it well. Okay, so for lambdas, there are quite a few ways you can call. Just now we tried to do it via the CLI, via via the like lambda invoke action, right? You can also do it via HTTPS endpoint. So we use or rather the challenge, they define a HTTPS endpoint at the API. Oh, sorry. No, this one is another one. This is another way you can call. The API gateway one that you're seeing, they're using the AWS SDK to invoke the function in the back end lah. So when you call the REST API, the REST API use the AWS SDK to invoke the function, right? There are some other ways that you can do it also. I'll just skip the deploying our own lambda. Then you can try your own. I'll just walk through the screenshot. So you can see here, you can define the runtime. So instead of OS, right, we have certain runtimes that we can put here. So you can put Node.js. If you are running your JS function, then you put Node.js. You can put Python, etc. Then you can see here also, after you deploy it, right, this is the function URL which you can call. So if you configure your Lambda correctly, you can call your Lambda from this function URL instead of invoking from the CLI. And your Lambda also has a certain execution role defined for it. So if let's say if your Lambda gets compromised, right, this role will also be compromised. So you need to make sure the permissions for this role is set well lah. And later on you see how you can actually compromise this role. Okay, so I have I created a Lambda on my own already last time. I will just show you guys briefly. Okay. AWS Lambda list functions. I always forget the region. Region AP Southeast 1. Okay, so I created this test Lambda. I was just like playing around with it lah. Let's try to get some details about this Lambda. So if you run AWS Lambda get function name, this one, then you see at the bottom, right, they will have this file. Okay, before you see this file, you can see some details about the Lambda lah. You can see the ARN, you can see the runtime, you can see the role that was created to execute this Lambda as. And at the bottom, right, you can see the Lambda code. So this is the code of the Lambda, or rather, this link will allow you to download the code for the Lambda lah. Lambda lah. Okay, let's go ahead and download it. I'm gonna put it in my temp folder.
This one is the in real life condition. This one is real life condition. In the day file where he's trainer me.
Is this file correct? Yes, it is correct. So when you download it, right, it will be a zip file. You can unzip the file, and then inside the zip file there is just one function, one file. In this case, because my runtime is Python, so it's a Python file. And we open it, right, this is the code that I put inside the Lambda. But you can see this one is specifically meant for me to run commands inside the Lambda. But yeah, okay, anyway, so inside the zip file that I downloaded was this lambda function.py, and inside lambda function.py, the function that will be run when I invoke the Lambda, right, is this Lambda handler function. Yeah, and then everything in here will be invoked. So I'll just give you an example in invocation of this Lambda. AWS Lambda invoke function name I.YCEP test Lambda, and you can specify arguments as well. I think you just put them. Just put them where? Payload. Put it under payload. So invoke function name I.YCEP test Lambda payload, and the payload that you have to put in is JSON payload. And you can see here the object that you want to put in is, the object that you want to put in as the payload has a command attribute lah. So you can put it in command, let's say ls-le. Out file. For out file, you can just put /dev as standard out if you don't want to like save many files in your disk. AP Southeast 1. Oh, shucks, this is, sorry, this one is AWS CLI v2. For v1 you can put it in plain text. In v2 they ask for it in base 64. Yeah, Anyway, I'll just show you in the slides. I have it in the slides as well. So, like this. Can see here this one. If you put payload like this, right, then you can invoke. Then it will run your command lah. Yeah. But if you go back first, okay. So that was the source of the lambda. That's how you invoke lambda. Then, if you have permissions to update the function code of the lambda, right, then essentially you can change what the lambda is doing already. So let's say we do have permissions. Then what you can do is we, you can see here, I have permissions. I have this policy that allows me to execute the update function code action on the lambda, right? So in the same way that I downloaded the file, right, the zip file has a lambda function.py inside. In the same fashion, I'm going to create a zip file with a lambda function.py and with my own lambda handler inside. Then I zip it up and then I run the update function code action. Then you change what the lambda does. And you specify zip file here. Zip file, you need to do this funny file B thing over here. Yeah, anyway, then you can see when I execute the lambda again, it will change it to, it will change from, this is a normal lambda to Samuzara was here. So like this, you can already change it to like something like this, right? You change to some RCE like this, then basically you have RCE over the lambda lah. So with RCE over the lambda, right, that's one way to compromise the lambda. How else can we actually compromise the lambda? So let's get all this. I'll go back to this later. No, sorry, I don't have a slide for that. Okay. Okay. What if you wanted to get the execution user, the execution IAM that is attached to this lambda? For lambdas, right, it's not defined at the IMDS endpoints. Defined inside the environment variables lah. So if you check the environment variables, you can see here there's a AWS secret access key. Yes, AWS session token. So it's a short-lived token. AWS access key, AWS secret access key. So this lambda, when you check the environment variables, you'll be able to get a short-lived access token with the permissions of this user. This is the execution. This is the execution user or the execution role. And this user was defined earlier when we created the lambda here. This is the execution role. So that's how it all ties in together. Yeah. Okay, there's another interesting way to exploit lambdas. So in lambdas, right, even though we say that every instance of the lambda that we create is a serverless instance, right, but actually in AWS, they are not truly like separate from each other. They're not individual lah. I mean, they're not really isolated. So to save on execution time, right, when you first invoke a lambda, AWS will need to spin up the container for the lambda, and then after that initialize the OS and then execute your function, right? So that's called a cold start because it needs to start from scratch. It needs to build a container from scratch. There's also warm start. So if you invoke the lambda again within a certain timeout, which is around 5 to 15 minutes now, depending on how long your lambda takes to run. So if you execute the lambda again before the timeout, right, instead of doing a cold start, AWS will do a warm start for your lambda. And warm start doesn't involve spinning up the instance again. It will just execute the function straight away. So between warm starts, right, since the instance is shared, the file system must also be shared, right? So in a lambda, if you go and play around with your own lambda, right, you can see that the /temp directory is writable. So usually /temp is used for it. Let's say you want to store something that can be reused across multiple instances, then you put it in /temp. And between warm starts, this /temp directory is not clear, right? So if your Lambda, this is a very contrived scenario, but if your Lambda put some like sensitive user data inside /temp, right, then as long as it is within the same warm start cycle, you never exited the timeout and trigger a cold start, right? You can actually access all the files in the /temp directory. So might allow you to get certain privileged information that you're not supposed to get. Yeah. Okay, so here's an example. So over here you can see I just made these slides a few days ago. But over here you can see, so I in the /temp directory, right, there's nothing inside. Right? Then I create a new text file inside. If I execute the Lambda again within 15 minutes, right? Before 15 minutes, right? So you can see 14 seconds later I executed it again. The file is still there, right? But after 15 minutes, so I waited 15 minutes here. Then I ls/temp again, right? The file is gone. So you can see here how the cold and warm start thing is.
I think it's the easiest one though.
You can see what's going on lah.
Advanced
yeah. And with that, you are done with the AWS workshop.
Oh, this is what we should be doing.
This was the other IM challenge that I wanted to let you guys try. It's really fun. It's a lot harder than Floors.cloud, right? If you want, you all can go and try. Yeah. Then go and get the cert.